There we go. Okay, thank you, Chris, who's apparently monitoring our every move. To make sure those of us who are technologically slow in the morning are not messing things up. Welcome to the day number 2 of our NASA and the Environment conference. Thanks to everybody, and particularly Brian for setting everything up. My name is Josh Howe. I'm the moderator for this panel. This is the one that I requested to be on because of the topic of the panel and the specific subject matter of the talks, which I find fascinating. Today we're talking about deep space and deep time together, which I'm pretty excited about. So our first presenter will go, everybody will have about 10 minutes. I'll have a timer. The timer will go off probably during your talk. That means your time is over and you probably should wrap up quickly.
Nothing happened there. Just
Wheels are coming off the wagon. The first presenter today is Andy Bruno. Sorry, Andy. Who's Associate Professor of History and Environmental Studies at Northern Illinois University and the author of The Nature of Soviet Power and Arctic Environmental History, which came out in 2016. He's got a new book out. It's there. Tunguska, Siberian Mystery and Its Environmental Legacy. He has worked on that book with help from a fellowship in aerospace history from the History of Science Society and the National Aeronautics and Space Administration, which you might have heard of. So thank you, and take it away, Andy.
I'm going to do the enable on editing, I think, and then will it let me do the full mode? All right, thanks everyone. Thanks for, it's been a very stimulating, and I'm going to make myself smaller so I don't look at myself. Okay, thanks everyone. This is part of a larger project that's just kind of coming to completion about this Tunguska explosion. And today, though, I want to try to focus on the NES angle as much as I'm ready to do so. So just a little bit about what this event was. It was in 1908. Most likely the largest known asteroid incident, meteorite explosion in modern times for the last several hundred years, although there might be some unknown ones we figure out at some point. That it occurred in June 30th this time, June 17th old time, in the middle of Siberia. It devastates a huge area of forest about this size, with putting out, knocking down trees in parallel rows, often uprooting them. So, not just knocking them over, but fully uprooting some of them. And it's in a very remote part of Siberia, though it makes a bit of a splash at the time in terms of local newspapers. It gets forgotten about until the 1920s when there's an expedition goes out there. They don't discover the expected crater or meteorite that they were thinking there. And it soon then becomes fodder for all sorts of interesting theories, including that it was an alien spaceship that operating on nuclear power that exploded there, Nikola Tesla and his death ray, all sorts of things like that. And I'll get to, I don't want to give too much away, but I wanted to give a little bit of the background on the place. In the larger book, one of the main things I'm emphasizing is the role of mystery as sort of a force in environmental history, to keep with a rhyme here. And what I mean by that is both mystery in terms of the unknown elements of the non-human world, the unknown aspects that might never be fully known. It's not necessarily, there's no guarantee that the scientific enterprise is going to ever fully absorb everything that there is to know about it. But also then the cultural process of defining this as a mystery, labeling it as a mystery, interacting with this landscape as a mystery. And I see these cultural and environmental roles of mystery in both the set of in three things: the set of practices that get applied to this place, the porous borders between science and what might not be fully science, and allowing alternative knowledge to kind of become part of the scientific enterprise. And then particular approaches to thinking about disasters and cosmic disasters in particular, I think are all sort of influenced by this force of mystery. That's not what I want to talk about today. That's what I just wanted to quickly give some of the larger ideas of the book. Because in the book, I really do highlight the Russian-Soviet story. I'm glad I did. I don't think I could do this research anymore. But I also, of course, am interested in the international aspect, including NASA's role. And NASA's role, unsurprisingly, if you were at the NEO talk yesterday, comes in late in the game because they're NASA. Well, first off, of course, NASA is only formed about half century after the blast occurs, but then also, even for then, it doesn't, the thinking about near-Earth objects isn't the highest thing on the NASA agenda until really the late 80s and 90s. But it plays, despite that, it plays a very fundamental role in shifting the conversation about Tunguska, and I'll get to that in a little bit. It's also just important in terms of the larger ideas about asteroids and near-Earth objects. NASA scientist and NEO specialist Dan Yeomans, in one of his books, points to a Donald Duck cartoon from 1960 that's like this crazy whatever thing in space, and it's like, actually, that's kind of closer to what we understand asteroids as asteroids might be today than what most planetary scientists in 1960 thought, right? So I think that whole, just the massive improvement in understanding space objects in the near solar system is part of that. The thing I want to really highlight though today is that what I feel is there's two sort of divergent visions of the actual Siberian environment. So I'm an environmental historian first and foremost, and the topology that was put out by Neil last night, I definitely swear in the environmental history, then history of science, then maybe space history, but not, very much environmental historian. And so I wanted to think about environmental visions. And I think we can distinguish two types of environmental visions, both from the Soviet side, which really thought about the environment where Tunguska occurred as a very special, particular place that required sort of approaching it and grasping its nuances and a full array of ideas in order to understand what might have happened there in 1908. And then the international and NASA sort of researchers who mostly view it as an analog, Tunguska as a site of comparison that we can glean information about near-Earth objects and asteroids. And the matter features matter for what they shed on that, but not for this sort of special aura. Okay? And I want to be clear that in the Soviet case, I'm not just talking about some of the later people interested in paranormal explanations. I'm also talking about the sort of sort of Academy of Sciences researchers as well. So the first expedition to get out there, it's arduous. It's in the 1920s. And it's this one guy, Leonid Kulik, who's just completely committed to this project of finding a meteorite out, the Tunguska meteorite, because he recognizes how big the explosion was, and has a lot of trouble finding it, despite being like, oh, it must be in this this thermokarst divot. We'll drain it, and then they find nothing there, right? But he spends multiple times, almost dies several times, all of this, but he is completely committed to this idea that you have to be there and you have to go there and you have to find this evidence on the ground. This idea comes picked up later after the rise of these alternative theories that initially come up from science fiction, that Tunguska was a nuclear explosion right after World War II, but then inspires these voluntary expeditions that start in the late 1950s and go through the end of the Soviet period. There's been over 40 of these expeditions that go out to the site. And they are completely committed to fieldwork, right? They think any sort of idea of just looking at afar, you have to do everything. You have to, take peat samples. You have to measure the azimuths of the trees that felled. You have to do aerial surveys, all sorts of things, but it has to be on the ground to actually be able to grasp the chaos of the site. This also, of course, they're not only going, these voluntary expeditions aren't only going out there for research, they're also going out there because it's kind of a tourist activity. So, the communal campfires and things like that, it becomes a place of escape for a lot of young Siberian students, not a lot, but hundreds, in the 50s, 60s, and 70s. And also this whole idea of it being a special place later comes into play with the successful efforts to turn it into a nature reserve, right? A nature reserve, particularly for the sake of preserving the evidence of the blast of 1908, right? That was the main logic of that. That is the main logic of the nature reserve. And I think that contrasts somewhat with the international view. So I'm going to talk about the international, and then I'll focus on NASA, where pretty early on, from like late 20s, early 30s, it becomes a site of speculation. And you have people like Harlow Shapley, who's one of the, it's a side comment, but he's one of the first people who says maybe it was a comet instead of an asteroid, right? And then some of the wild theories actually about this blast, not the wildest, but some of the wild ones, like it being antimatter, that come from meteorite specialist Lincoln LaPaz, but then also independently by Cowan, who did research, was involved in experimental research to find detect neutrinos, and Willard Libby, who invented radiocarbon dating. And they say maybe it was antimatter, right? Again, in the 1970s, you have this idea that maybe it was a miniature black hole, right? These are all kind of responding to advances in physics and astrophysics at the time. So it becomes, except for a little bit right at the, starting at the collapse of the Soviet Union, where researchers are allowed to go back, there's not much on-site research that's occurring from the international researchers. The one main exception is this team from Bologna that becomes very committed, kind of, they're not going to be satisfied until they find meteoritic material, and they haven't. But this also is reflected in the fact that starting in 2015, they named International Asteroid Day on the anniversary of Tunguska, which it reflects this vision of the environment as something that helps. The environment is what helps us think about space, not the circumstances on the ground itself. And finally, with NASA, and I realize I'm out of time, but I'm going to be, so I'll be quick, but not too quick. When NASA, the very earliest researches of NASA on this event pretty much changed the conversation quite dramatically. The dominant mainstream interpretation of Tunguska from the 1960s to the 1980s was that it was a comet. This is what the Soviet Academy of Sciences concluded after their expeditions. And it was people like Zendy Sakina and later these other authors who really put the idea that no, the most logical explanation is a stony asteroid that had an airburst explosion, right? And to the extent that it's been solved, which it's mostly been solved, but people would be happier if they actually found, meteoritic material somewhere on the ground that definitely was from 1908. It was a NASA explanation that kind of came from its early work in NEOs and stuff like that. And that's continued to this day. I mean, the Planetary Defense branch of NASA had a whole symposium about Tunguska in December 2018, which was, particularly about using this event for how we might understand the threat of asteroids today for the world. So I would just say that this is also, this is in line with the international one, but is a quite different view of what the environment, the value and use of the Tunguska environment than what the Soviet researchers had developed, and I'd even say what the nature reserve has today. Thank you. And I will just say one thing. So one thing about the value of the Soviet perspective that I just want to hit on is that it's like, this can't happen anymore. Like getting to a helicopter in the site can't happen anymore because of the window of opportunity. So, I do think that on-site research ends up having certain value, even if it didn't end up being as decisive in figuring out what happened in 1908. Thank you.
Next presenter is not Dan Irwin. Our next presenter is Kelsey Herndon, who's a research scientist at NASA Server Science Coordination Office at the NASA Marshall Space Flight Center. Before her current position, Kelsey served as Amazonia Regional Science Associate at NASA Server. She holds a master's in science in Earth System Science from the University of Alabama, as well as a Master of Arts in Anthropology from the University of Alabama. So she's going to talk to us about the 17 years of Server and the Server programs. Please welcome Kelsey.
Thank you so much. And Dan sends his regrets. He really wishes he could be here to present, but I am happy to share with you guys the history of a really unique program that NASA has called SERVIR. So SERVIR is a joint initiative of NASA, USAID, and leading geospatial organizations around the world. And we partner with countries and organizations in these regions to address critical challenges in climate change and food security, water and water-related disasters like flooding, land use, and air quality. And SERVIR has 5 hubs around the globe in the Amazon region, West Africa, Eastern and Southern Africa, the Himalaya region, and the Mekong region. And the way that SERVIR operates is really unique. We have a process called co-development. So rather than having US-based scientists develop solutions to these environmental challenges and then kind of tossing them to our stakeholders in these regions, we actually sit down and work hand in hand with our partners to develop solutions. And this can mean anything from, sitting down in a room coding together, or giving a workshop on remote sensing fundamentals, or teaching coding, or working on how to interpret the results of some of these services. So it's a really unique perspective. So SERVIR has dozens of services, but today I'm just going to share 2 examples with you guys. The first is crop mapping in Kenya. And for farmers in East Africa, microinsurance is a way that farmers can cope with drought. And it was really expensive for the Kenyan government to support these kind of insurance programs. And so they worked with SERVIR to use satellite remote sensing to map and assess crop area and conditions at scale. And this was a much more inexpensive way to do this type of mapping to support crop insurance programs. And the amazing thing is that they were able to reduce costs by 70%, which allowed the Kenyan government to scale up their insurance program. So they went from insuring 900 farmers to 1.4 million farmers. And there's some interesting work that we're doing now to specifically target women farmers in Kenya. And so we're continuing those efforts. The second service that I want to share with you guys today is improved severe weather forecast in Bangladesh. And you may not know this, but Bangladesh has the most deaths from lightning of any country in the world. And so there is this need to improve our forecasting abilities to kind of protect people, to let them know when they should go inside. They should not be out in the middle of a storm. So this tool was developed, the high impact weather assessment tool, co-developed with forecasters in the region. And there's been amazing uptake by the Bangladesh Meteorological Department and the Department of Agriculture Extension. So they're able to put out these timely alerts to warn farmers, but also just warn anyone who's out and about. And the kind of cool part about this is like, okay, great, they've developed this assessment tool, they have it implemented in the meteorological service, but they've also developed something called BAMC, which is this comprehensive outreach component. So they send out things like text messages, and they send information on the web. They send, all sorts of different ways that they can try and reach people. And that's kind of one of the innovations with this particular service. So this is just how SERVIR exists today, but it hasn't always looked that way. And in fact, SERVIR has a really interesting origin story. I think it's interesting. In the late 1990s, Dan Irwin, who's one of the founders of Surveyor, he was living and working in Guatemala, doing some field mapping of the newly minted Maya Biosphere Reserve. So he was in the field, 3 weeks out of every month, trekking through the jungle. He comes in from the field one week, goes into his kind of local restaurant haunt, and sitting at a table across the room is a NASA space archaeologist, Tom Seaver. And I think you guys might hear about him a little bit in the next talk. But Tom rolls out this giant printout of Landsat imagery. And Dan is just kind of flabbergasted. He's like, I've spent the past year in the field trying to map what this rollout map has on it. And so that was the beginning of this really kind of exciting collaboration between the NASA space archaeologist, Tom Seaver, and Dan. And Tom took Dan back with him to NASA Marshall. And they actually worked on a bunch of this archaeology and remote sensing for a long time. But in 2002, they had the opportunity to present some of the archaeology research to the CCAD, which is the Central American Ministerial Conference. And they revisited this idea that remote sensing could be used not just to inform about the past, but also inform about the present, and specifically some of the interesting and challenging problems that Central American countries were having related to the environment. So there was a lunch break. Dan rushes back to his computer and he mocks up this idea of the first version of Surveyor, which you guys can see right here in the bottom right. And the concept was it would be a one-stop shop for geospatial data to help support some of these countries who couldn't really get access to a lot of the imagery that NASA was producing. Out of that, the Central American partners, they were really excited about the idea. So NASA, Tom and Dan put together a NASA reason proposal, which was funded, and later they brought in USAID as a partner as well. And so you can see over the past 17 years, Surveyor has been able to expand from this initial one-stop shop concept to the global network that it is today. And that was in large part due to a lot of the support that we had from NASA and from the administration. So you can see in the middle four hubs, those are all pictures that include the NASA administrator at the time. So he was a big supporter of the work that Surveyor did. But Surveyor was not just a result of administrative support or ideas from Dan and Tom. They are part of this broader scientific trends. And three of the things we had kind of fun thinking about, what are the movements that Surveyor has been a part of? And those are open science, kind of technological advances in compute resources, and this idea of capacity building. So Surveyor, as I mentioned earlier, was originally proposed as a one-stop shop for geospatial data. And that was in large part due because none of this data was easily accessible or freely accessible. And in 2008, when the Landsat archive was open, that was transformative for the type of work that Surveyor was able to do. So instead of just procuring the data from NASA and sharing it with our end users, we're actually able to refocus our efforts on things like, how do we do the best science related to this imagery? How can we have sustained capacity building with our partners? The second thing is compute resources. So in the early stages, Surveyor was really doing these kind of one-off analyses on single scenes of imagery from satellites. And that was in large part because the compute power necessary was not easily available. And so the advent of things like GPU and greater processing power, and especially cloud computing, has had a really big impact on the type of kind of sustained services that we can provide. So it's not just doing these kind of one-off analyses, right? Now we can provide kind of near real-time monitoring. We can take full advantage of EO's big data to address a lot of these major environmental challenges. And then the last thing, and maybe the most transformative, has been Surveyor's engagement with this idea of capacity building. So originally, as I mentioned earlier, we developed these solutions and then kind of passed them off to our end users and just hoped that there was uptake, that people used them, that they had an impact. But through this idea of capacity building and through this idea of co-development, now Surveyor provides demand-driven solutions. So we're working hand in hand with our partners in the regions, and we are committed to kind of this long-term institutional capacity building. So I will leave it at that. That's a brief history of Surveyor, which is, again, is kind of a unique program within NASA. And thank you guys so much for the opportunity to share. Yeah.
Yeah, if I'm not mistaken, I think we might have a video from Dr. Murtha, but I could be wrong about that. Okay, so I think we do have a video from Dr. Murtha. Timothy Murtha is a professor in the Center for Latin American Studies and the School of Landscape Architecture and Planning at the University of Florida. He's an anthropologist, a landscape archaeologist, and design educator with over 20 years of research studying settlement patterns and landscape history in the Maya lowlands. He's a founding faculty member of the Florida Institute of Built Environment Resilience, and his research investigates the coupled natural human systems dynamics of settlement and land use, relying on advanced geospatial tools. And I will leave it to Dr. Murtha.
Hi, everyone from Florida. Sorry I can't be there because of Hurricane Ian. Apologize for my absence, but I'm still very grateful for the opportunity to present. And while I'm out front presenting today, this work stands on the shoulders of many giants, not only from the past, but the great team of scientists, students, and collaborators we have. I've tried to tightly organize today's talk to offer a brief introduction and broad arc of remote sensing and archaeology, including the space archaeology program. Describe how this early work was transformative, not because of an emphasis on discoveries, but on systems, and in particular, agricultural and ecological systems. To speak specifically how early work at Tikal led us to new perspectives on ancient Maya cities, and to introduce how we're now using these data to ask broader questions about the overall ancient Maya landscape. While there has been recent popular focus on discoveries driven by LiDAR and archaeological research, NASA scientists and products have been important tools for archaeologists and anthropologists for over 50 years. Certainly, the recent use of LiDAR has allowed for rapid, precise, and accurate site documentation. However, the transformative research by NASA applying remote sensing in archaeology and anthropology was initially focused not on discovering sites, but understanding systems. Early work was focused on understanding coupled and natural human systems, advancing our understandings of the past beyond simple site discovery. Viewing archaeological sites from space generated new questions about our shared human history and the expanded scale of the questions we could ask. At a 1990 conference at the Stennis Space Center, this evidenced how tightly coupled remote sensing was linked to questions of human settlement, cultural and historical ecology. Behrens investigated the Amazon through the lens of cultural ecology, while Miller and colleagues directly applied ecological concepts and remote sensing for archaeology. Simply, the power and promise of remote sensing wasn't solely focused on discovering sites, but on critical anthropological questions about the human environmental dynamics that can only be interpreted from the relationships among sites, features, and landscapes at a large scale. So today I will only offer a brief historical review of remote sensing driven by NASA scientists. Anthropologists and archaeologists are using these data to reconstruct land use histories, document transformed and engineered landscapes, and to evaluate carrying capacities of regional cities and settlement systems. The systems-based research offers a new window of perception into the past by emphasizing how cities shaped and were shaped by their regions. Perhaps most important, though, this work is providing information about critical global and comparative narratives about our shared past, allowing us to move beyond discoveries and view past landscapes as an artifact of our decisions, as reflected in this quote from Pierce Lewis. Tom Seaver really opened the door to remote sensing and archaeology several decades ago, even before this 2003 publication shown here. Tom worked across the planet, but for me, his impact was critical in the Maya lowlands. He mentored and advised many friends and colleagues, cultivating the next generation of remote sensing archaeologists, including Dr. Rob Griffin, who's not only shown in this photo here, but is also a partner in our research today. Therefore, to frame my essay, I will rely on research from this location, the ancient Maya lowlands, illustrated here. It's where we work today and has uniquely leveraged remote sensing because of the vast tropical forests found in this region. Aerial perspectives changed the way we thought about ancient Maya society and ancient Maya history. Early studies emphasized subtle features such as raised fields shown here and the broader landscape, especially potential agricultural features beyond the ancient city centers. These data allowed archaeologists to think at a new regional scale. But it wasn't just raised fields and it wasn't just a new scale. It was terraces in the Rio Bec region. And it was a changing perspective about the Maya. Because of these early images, significant questions about the carrying capacity of the lowlands were being asked. These images directly challenged some spurious early notions about ancient Maya cities and populations across the lowlands. Simply, early scholars thought the forests were unsuitable for long-term and sustained cultivation. These data directly challenged those perspectives. Central to these changing perspectives is the ancient Maya city of Tikal. At the time, Tikal was well known for its impressive art and architecture and towering buildings poking above the canopy of the forest. Tikal is a magnificent city, but for decades we knew very little about the region and how the city shaped and was shaped by the environment and ecological systems. Tom Seaver and Dan Irwin radically shifted attention from the massive buildings, art, architecture, and urbanism at Tikal when they published some of the first images of the Tikal region, indicating clear signs of human activity in the swampy bajos and wetlands east of the city, previously perceived to be unsuitable for cultivation. My colleagues and I at Penn State followed up their transformative work to look more expansively at land and water resources at Tikal beginning in 2012. Like Tom and Dan, instead of starting at the city center and simply viewing the region as a supporting feature of the city, we aim to view how the city was shaped from the region and from a cultural and an ecological perspective. Summarizing some of our results, we found that the city center to the furthest household from the hill slopes to the very bajos first visualized by Tom and Dan's research, evidence for agriculture was all over the city of Tikal. It was truly a garden city, despite the dense core of architecture in the city center. We also documented that the earliest residents of Tikal had the most significant impact on their landscape through erosion. The erosion shifted a rather well-distributed natural resource, productive soil, to large contiguous tracts of productive land at bajo margins, foot slopes, and toe slopes. Relying on the results of our soil tests, we returned to remote sensing to examine a full regional pattern of productive landscapes and attempting to quantify and identify where sustainable production of landscape may have occurred, but also how it compared to the past distribution of people and communities. The simple story is that the distributions of land and water greatly influenced Tikal city form. Instead of packing thousands of households together in high density surrounded by an agrarian landscape, Tikal reflected an early form of ecological urbanism where productive agrarian space was interspersed with households and neighborhoods. We wrapped up our research in Tikal in 2017 and started asking questions about all Maya cities. Were they all similar? To address this core question, we embarked on a multi-year spatially distributed research project, initially supported by the NSF and more recently by NASA's Space Archaeology program. While we began in 2017, it was with an inventory and analysis of extensive LiDAR transects extending from the state of Chiapas north to the Yucatan and Quintana Roo. The overarching purpose of our research is to investigate long-term patterns of landscape resilience in the lowlands. To do so, we're collaborating as an interdisciplinary and international team of researchers from Mexico, Canada, and the United States, led by faculty from the University of Florida. We're investigating these landscapes by relying on advanced geospatial technologies, field survey, soil science, remote sensing, and specifically mapping technology developed by Florida's own Gatoride team. We begin our research, though, by repurposing massive amounts of big data originally collected by NASA for environmental surveys of above-ground carbon storage. Stripping the vegetation revealed incredibly complex and clearly long-term patterns of land use across the lowlands and across thousands of kilometers of Mexico. Today, much of the region is completely covered by tropical forests, but it's clear that in the past, dense settlements and intensive land use cover the Maya lowlands. Much of the exploration of the lowlands had been focused on big architecture and warfare, but we're investigating a different story, a story about household, community, and landscape resilience. Thousands of households and terraces are situated in complex patterns across this forested landscape for hundreds of years. People and communities adapted to changing environmental conditions and rainfall, designing what appears to be a resilient mosaic of land use, including terraces for cultivating corn and other crops, and even catchment features for conveying and storing water. To better document and understand how these systems were designed, we embarked on this project. We processed 458 samples and documented thousands of features, big and small, including structures, platforms, plazas, aguadas, borrow pits for building construction, walls, canals, ditches, and paths. But importantly, we've also identified critical systems. For example, we've identified communities on the landscape that appear to have multiple phases of occupation and construction, where earlier forms of the community were located in lowland areas of the site and later moving upslope. We've also identified complex systems that are not just dominated by one type of feature, such as buildings or terraces. They include complex systems of water management along with terrace management, and new features and patterns across the landscape, such as these canal systems located in southern Chiapas. This work has opened up new questions and new techniques. For example, shown here is a predictive model combining environmental predictors with archaeological inventories, just like we completed for Tikal. Our preliminary results suggest that open space defines the lowland Maya landscape in very complex ways. Unlike traditional city models, which describe high densities packed into centers of sites, declining densities at the outskirts surrounded by rural agrarian areas, the eventually wild areas, the Maya landscape is defined by open spaces of varying qualities and size. With these analyses underway, it's clear that we need to focus on ways to combine data sources and information about this landscape. This will first focus on data integration between our drone, airborne, and some space systems. Our work also allows us to ask bigger questions at a bigger scale. So instead of wondering how one city managed resources and land use, we can start to investigate how different strategies were applied across the landscape. For example, shown here are our first analyses of where terraces were constructed and how that relates to core environmental variables and what we know about the distribution of population and communities. We're even starting to ask questions about how social inequality was distributed across this important landscape. Finally, led by Kelsey Herndon, we're also experimenting with Google Earth Engine to better understand the deep legacy of past land use on modern land use. Shown here are 5-year composites we're developing as we aim to examine, again, how modern land use shifts are potentially influenced by centuries of past land use. One of my academic heroes, Dennis Puliston, once wrote, "Surely the brilliance and magnitude of ancient Maya achievements are a reflection of an entire network of stable and harmonious adjustments to the special conditions found in the tropical forest environment." I honestly don't know if all the achievements and all of the decisions were stable and harmonious, but I do know that there's a critical landscape narrative embedded in the Maya lowlands that we need to preserve, document, and share. All across our planet, these narratives exist, and it's because of the history of remote sensing and archaeology, and especially because of NASA, that we can start to address these questions systematically. Thanks a lot for your time and hope to see you soon.
Get out of here. That went poorly. Okay. Our final presentation is by Thomas Bosniak. Everybody sent me bios that are sort of academic in nature, and Thomas's includes other information that's sort of irresistible. Thomas grew up as an active Catholic under the communist regime in the GDR. And when the wall came down, he did the civil service instead of joining the army and worked with the disabled population in Israel. And after returning overland by bike, tracing the Crusades, he decided to study history. For the analysis of 3 late medieval taxation lists, which came to light during renovation work in his father's house, an old half-timbered building, he earned his MS, and after he completed his dissertation at the University of Cologne in 2009, he worked until 2015 at the University of Marburg and finished his second book about natural events in the early Middle Ages in 2017 in Tübingen. This is followed by a professorship in Tübingen and Munich, a guest lectureship at Weber State University, just outside of Ogden, or is it in Ogden? No. In Ogden, Utah. In 2021, he had a fellowship Asian Studies at the University of Heidelberg, and he currently teaches at the Eberhard Klaus University back in Tübingen. So welcome, Thomas.
This is the second book. You know, I tried to put it in 10 minutes. So thanks, Josh, for the nice introduction. My presentation deals with 3 different questions. First, I will discuss the types of natural and celestial events recorded in medieval sources. Second, how and for what purpose the historiographers record these events. And third, I will examine how solar eclipses are reflected in those sources. I need to stress that written sources from the early Middle Ages, which is from 500 to 1100, are very limited. Not everything that happened was recorded, and not all the records survived. This is my measuring grid. Over the last years, I studied more than 150 different sources from the 6th to the 11th century, and have been able to identify more than 1,175 natural and celestial events. You can see here, for example, excerpts from the Annales Admontenses, which were written in the monastery of Admont, is today Austria. The single entries are often quite short, mostly no longer than a tweet or a text message today, and provide us with different kinds of information, such as earthquakes, famine, hunger, or signs in the sky. for the majority of such natural events during the early Middle Ages, we don't have any other written sources. It is as if you had to reconstruct the current COVID-19 pandemic only on the basis on a few tweets. Another methodological problem arises from the fact that the monks often used to write those manuscripts and often copied older manuscripts. Therefore, older observations, sometimes deriving from other regions, were integrated into new manuscripts. The writers made their own choices, copied one entry and skipped another. So this approach makes it very hard for us today to understand which entry made it into the surviving text and which not. Historians developed, therefore, a method to help themselves and created so-called tradition groups. You can see them here. Sources that are in a special relation with each other. Dealing with the surviving records is very complex and raises multiple problems. The main problem is that medieval sources tend to mention only the most extreme events. Most times, only these extreme events are handed down. Another problem is the possibility or impossibility of observation. Earlier studies often neglected the types of localities at which natural events could be perceived. However, we must acknowledge that there are some events which can be perceived only in the wide of a valley, like a landslide, whilst other phenomena, like comets or supernovae, can be observed from almost any point worldwide. The possibility of observing natural events and recording them are thus dependent on a radius of distance. Apart from the observation area, there is another important factor that shapes the tradition. This is the audience the writer has in mind. European historiographers targeted specific audiences with their work, each of which had their own expectations, often shaped by monastic life and the study of sacred writings such as the Bible. To give an example, let's look at the year 873. When a swarm of locusts appeared, the analyst of Fulda, a monk living in the center of what is Germany today, and a lot of his colleagues in other monasteries were able to see the locusts with their own eyes. But even as he experienced them himself, he used his observations not to report accordingly to the truth, but as part of a biblical pattern. The huge swarm of locusts reminded him of what is told in the book of Revelation. In John's books, in John's Apocalypse, 7 angels come, each blowing a trumpet in turn and bringing the 7 last plagues. The coming of the locusts is a sign that the 5th trumpet, those had begun. When further examining our text, we notice this. We notice that just in the following year, 874, the analyst mentions a terrible famine followed by a plague that killed 1/3 of all the people in Gaul in Germany. Other contemporary sources would definitely record to such a disastrous event. Instead, no other source mentions it. Only the analyst of Fulda described this extreme impact, and he follows the narrative of the book of Revelation. Trying to integrate more signs of apocalypse into his text, the analyst didn't stop here and invented other natural events in his text. Since antiquity, celestial phenomena have been observed and interpreted as signs and miracles. Roman authors interpreted the appearance of unusual astronomical phenomena, new stars, comets, as an announcement of an existing reign coming to an end. Often those phenomena were also associated with wars, famines, epidemics, and other disasters. However, the dates often had to be adjusted between announcement end event. One finding of my work is that there are 3 types of events that allow for an independent verification of sources: the appearance of comets, solar and lunar eclipses. Solar eclipses, for example, can now be calculated to the nearest minute. Thanks to NASA, since 2007, there is a website offering all the dates of solar eclipses from 3000 BC to 2000 AD. This gives us the opportunity to compare the data given by written sources with the actually observable solar eclipse and to verify them. It results that the medieval sources in parts offer very, very exact dates, as solar eclipses can be observed in areas, in line areas that span over more than one continent. We can now look at sources from different cultures and compare their use and interpretations for the very same event. During each century, the Earth, Moon, Sun system shows 300 constellations of solar eclipses. About 10% of them can be observed in Europe or in China. And about 1% can be observed in Europe and China. Those rare events now offer the possibility to analyze the different approaches of synchronous observations of nature in historical sources. When a solar eclipse occurred on the 7th of June in 1415, a Bohemian chronicler noted the sun was entirely eclipsed, so that the Holy Mass could not be celebrated without lighting. This was a sign that Christ, the Son of Justice, had darkened the hearts of many prelates who were eager to put Master Jan Hus to death on decision of the council. The reformer Jan Hus had been condemned for heresy and burned at the stake at July the 6th. We see that the solar eclipse was used by a supporter of his cause. The very same eclipse was visible in China and gave warnings to the ruler to mend his way or else lose the rights to govern the realm. When experiencing disastrous events, medieval historiographers found themselves conflicting between expectations of the apocalypse on the one hand, the natural events of which were awaited to appear in line with John's vision, and the natural events they actually observed on the other hand. Not everyone chose to follow the holy writings. Therefore, we require a detailed analysis of each text with all its various implications regarding the historical context, the writer, and its background, the audience, as well as the biblical pattern under consideration. Especially in the case of the astronomical events, however, the calculations from NASA make it possible to check them very easily today, which allows us a more direct access to the reliability of historical sources. Thank you very much.
That would be great if the panelists could come up, and I've got to figure out how to try to get Dr. Murtha on the screen.
First we'll be hearing this a second.
Got it. I didn't mess it up. There it is. And Timothy, can you hear us?
I can. Can you hear me?
Yes, perfect. Thank you. Thank you all for these papers. It's fascinating stuff, and I've been sort of thinking about how to tie some of these things together methodologically and interpretively. And I was struck by this a paradox that Sam Weinberg introduces in an essay called "Historical Thinking and Other Unnatural Acts." Some of you might be familiar with. It's actually a teaching favorite of mine. The paradox was what he calls the paradox of presentism, where part of what the historian tries to do is to understand the context and contingency as it works in the period that they are studying, such that the past appears to be a foreign country where things work differently, to paraphrase another idea what the historian is doing. The paradox is that you don't come to history or any subject without some reason. You don't just sort of look under a rock and find an archive and decide, oh, well, I'm going to look. There's a certain amount of interest, but also speculation. And these talks, to me, brought up the relationship between speculation and observation in doing all kinds of scholarship. And so I'm particularly interested in hearing the panelists, and I figured I'd start off with a question, and then we'll turn to the audience who probably has much better and more interesting questions. But I wanted to ask first, selfishly, about the role of the relationship between speculation and observation in creating the new types of knowledge that I think each of these talks is interested in, either among your historical characters who are the analysts or these Soviet scientists, or among the people that you're working with to study the past and the present when we're looking at landscapes through geospatial data. So with that, I'm curious to know what you have to say about speculation and observation together. Figured I'd start off with a softball question, right?
We have 5 hours. I guess I would just say, okay, so I mean, there's 2 parts of, I think, your questions I find. One is applies to what I was talking about, or just whatever. One is about my own methods as a historian, and I mean, I think I have a lot of goals, right? Like I like the empirical data, I like that, but I don't actually think that the process of finding all these sources, finding these things is actually where I come up with my arguments and interpretations. Like this is kind of, again, historical methods 101, but it's like, you're immersed in the data, but then there's a creative act that actually kind of comes in to the process. And I don't really think that it's not like the evidence data sources lead to the only conclusion. It's more of a sort of dialectical process of thinking about it. So I don't know if that's kind of what you're getting. In terms of my scientists, though, I mean, oh my God, they love the speculations. I mean, it becomes almost, I didn't talk about it, but for a lot of these, both Soviet and abroad, and not really massive folks, but a lot of people thinking about computers both in the Soviet Union and abroad, it becomes almost this like, can I be the one person to figure it out? Right? Can I be the detective who cracks the case? And that becomes valorized as its own process. So there's obviously then they're bringing in observations, they're trying to like do that, but the speculation is actually really where they get their jollies, right? Like that's, so I don't know.
Yeah. To me, you have seen my data are very biased already. So if I give them more speculation, it's a problem. Like the example I showed, the analyst of Fulda, it took me several years to come behind this pattern. To me, it was always the most objective author in all my sources. And then after 5 or 6 years, I found out it's a biblical pattern behind it. And he was very good to hide it somehow in the text, that you cannot see it on the first view. You need to get into it really deep history. So speculations I cannot do.
Yeah, Dr. Murphy, I'm very excited to hear about this.
So speculation and observation is exactly, I think, a perfect way to discuss how we go about using these technologies and that kind of broader arc of what we've done. Because we find, I think one of the great things about our work, or the exciting part for me at least, is it does begin with speculation. So all those early first images were speculative at best. And then we design our science projects around how to answer those certain questions. But what's even more exciting, and this is why I think so many archaeologists never retire, is because in the process of that project, you encounter new observations in the field, and then sometimes at these larger scales when we're working with these data. I'm sure Kelsey can tell you all sorts of examples of that. It's kind of like that Tom and Dan dynamic. And then we start to ask new questions and try to develop new speculative approaches towards addressing that question. And the one that for me is most compelling and kind of links all these together is so much of what we do as humans make decisions in landscapes are based upon our observations while we're there. And so that role in fieldwork for us is really critical. But I still don't know if we have a good handle quantitatively and spatially as to how we process past actions and decisions that are embedded into these landscapes into our modern decision making. And so I think that's the real exciting part for me. It's almost as if the past then becomes this data set that is leveraged more importantly for the decisions we're making today, and not necessarily just about some trying to understand that past in its objective manner. I don't know if we'll ever get to the degree at which we can simply say, this is Maya history. We won't. But I think we will be able to kind of look at how it's influencing some of the patterns that we see shaping the decisions we're making today. And then hopefully, I think speculating about the relationships that we're seeing in some of these images can inform new ways of thinking about the decisions we make today. So I don't know if that really gets to your question, but to me, it's fascinating, and it's speculation and observation is operating for us at two scales. It's when we're in the field, but then also when we're back trying to process these data and these images to get a better, broader understanding.
So I'll just add a little bit, I guess, when we think about speculation and observation in terms of actually doing history like you guys are doing, that's kind of one way. But at Surveyor, we also operate at these kind of this exchange between speculation and observation. So we have these satellites, they're observing the Earth from space. We speculate about what those images may be showing us, but it's not until we actually engage with our partners and communities on the ground that we really get a true understanding of what the situation is, of what the process is. So we also have that, today in terms of the practice and the operations of Surveyor as a program.
Dagmar, and then go up the.
I had a question for Tim and for Thomas. These were all really fascinating papers. First, for Tim, I'm wondering if you could talk a little bit about the integration of paleoscientific data and the LiDAR data. We've got a lot of information on lions, for example, from paleo data, like lake bed sediments, problem data, and we built up this kind of picture of the complexity of lion ecological relationships, the scale of Mayan society, and the factors that might have contributed to the decline of Mayan city-states, in part from paleo data, right? I'm wondering how LiDAR data can kind of build on that, contribute to it, what the relationship is.
Tim, were you able to hear that question?
I think I got the gist of it. It got a little bit cloudy. And
Okay.
I think it was asking about like how our field or our scientific observations on site, such as like lake sediment cores, focusing on erosion and deforestation, and how that links to the broader remote sensing.
Yeah, the
And
relationship
also
between paleo data and LiDAR data was, I think, the specific those are the specific technologies, but that's the first part of the question. Then Dagmar wanted to ask a second part of the question.
Okay. Do you want to ask that now, or do you want me to go into the first part?
Go ahead and do it. Go ahead and ask it now.
All right. Also, Thomas, I love this paper, of course, as you know. I really love how you're using the data that I can be sure of, like the eclipses, right, the comets, to gain a sense of what people were actually seeing at the time, right? I loved how you also explained the elaboration, I guess, right, of the initial environmental site, right, report, and how that comes from, obviously, revelation rather than what was actually going on. I think this is a common mistake, right, as you know, that has been made by climate historians. Sorry, Vietnam is a good example of that, where they were building up this whole picture of how the medieval climate changed, right, based on uncritically reading documentary sources. However, I wonder, you mentioned the audience is really central here. I wonder also if the motivation for actually reporting environmental change is important as well. What I need to ask there is, can we be sure, outside of those cases of eclipses and comets and the stuff that NASA tells us about, can we be sure that somebody's actually initial report of, let's say, an extreme winter, that really happened? Or is that, the motivation for writing about that is that, not tied to what really going on in the environment. Hope that makes some sense.
So let's start with Tim on paleo data and LiDAR data together.
Sure. So if you look at most LiDAR applications in archaeology today, we're using 2% of the data, especially in the Maya lowlands, and they're becoming very much kind of inventory and documentation perspective. So I think that we have a lot of growth to work on in that side. But in some ways, what the LiDAR is really actively doing is improving the fidelity, the precision of the information that we have about specific locations. And then it allows us to connect it to these very particularistic, I mean, archaeology, we're really good, especially in the lowlands, about creating these very particularistic cultural histories that are kind of attached to sites. And that's very much driven by the paleo data that we capture at those sites, whether that's, for example, the work we did at Tikal, which was trace element analysis of the soils, looking at, and we did some radiocarbon dating there to look at patterns of production. So we had that narrative tight at the site. What the LiDAR is now allowing us to do is to kind of connect those observations beyond site boundaries. And for me, that's a real critical shift, because everything from permitting to all of our narratives in archaeology have been driven by this named place, like a geography that is very fixed. And for the first time, we are not fixed to that geography, because we can transcend it in kind of unique ways. But the complicating factor is, right, we have incomplete data sets from all these various places. So I think that's where I see our role coming into play from a kind of data integration perspective. So once we've identified using these transects that are connecting these places, we now have to mine the information, the paleo data from those regionally specific places and try to reattach that narrative from the outside in, as opposed from the inside out. We're just starting that. And then I also think that there's also, right, I mean, we really need to start using these LiDAR data in creative ways in archaeology, right? What I showed you was really basic inventories, 2% of the data. I think the more we push it, and that's why we've got the drone and the airborne involved, I think the more we push it, we're going to see other clues in those data sets and the full point clouds that will allow us to better understand places where we don't necessarily have features, because that's the absence of information in archaeology is always the tough one to deal with. So I don't know if that fully gets to the question. I'm happy to follow up, but I want to give Thomas his time.
This was just one example for a pattern. There are different patterns, and it's even important the personal background also. How is he educated? Which books he knows? Is he interested in nature at all? We have one other annals. They have 4 authors through time, through 200 centuries. And there are 2 which are not interested in nature at all. They give us no information about nature, just first and the last. So this is also a question. And sometimes it's also political documents in there, like there are the Frankish annals. They are like the official historiography for the Great, Charlemagne. And the writer was not allowed to introduce any astronomical event. So we know there are a lot of eclipses in his times from other sources, but not in this special case. So there are a lot of implications. And now my work is to find a different pattern, to look in the other sources, to find them there. Because we are still at the beginning to work, not at the end was the plan, before we can use any of this data to say, okay, now we are sure it's really reliable, it happens.
And you also use the proxy sources as a kind of verification.
Yeah, the problem with the proxy sources, I was thinking about. Actually, I came to the scene through a work from NASA, from Richard Stoddard, about the Edgar 10th century volcano. And I wanted to integrate the proxy data, but then I realized I have already so much bias data here, and that I don't want to have a circle bias, because a lot of the series we have, like ice-core series, they use sometimes historical data to synchronize. And if the historical data is not right, so then you have the double bias. So now I first have a look which historical data are really reliable. We have later then maybe some years some markers for the other. serious.
And then you better prime time is considered for freeing will be really high revenue, but then for growing seasons, right? So that's,
I know.
now, I got 14 months.
I know. Well, but the meteorology it has its own problems. Like what causes the white of rain? It's depending on the plant, on the location, on the water, on the soil, on very different factors. We don't know which factor is really responsible to build up the white of rain. Even there's a lot to do. So even this data are biased, and so we have to go further on to take out all this bias, and then we will manage to come together.
How about the data on historical earthquakes?
Yeah, I've also put. I have got 25 different categories, and also lots. And like in your questions, most emperors are responsible for the floods. So they came to the spot, looked, okay, do I have to help? Do I have to bring food here or something like this? So sometimes you will have small spots where you can see, okay, they arranged something, they organized this is flood, this is Hayne, stuff like this. Epidemics.
Did you have another question? Because your hand, okay, your hand was up before. So go ahead.
Andy, I was wondering if you could unpack something that I'm articulating. Going back to observations and the way science moves. Did you, when you were doing research for the book, did you spot tensions or conversations between the way Soviet science was done in the Tunguska case and, say, NASA or other Western agencies and entities that are more technology driven and more data driven, but not too keen on field studies and like picking soil something like that?
I mean, yes. Sorry, I'm having trouble thinking how I want to approach my answer. So, let me just give you this bit. So, like, a lot, like after the collapse of the Soviet Union, there's a lot of international scientists that come to the Tunguska site for brief visits, right? And there ends up being this deep resentment among the Russian scientists about the hierarchies and things like that. And oh, there's all these funding, and they're like, now we were like specialists, and now we're Sherpas just guiding these foreigners at the site, and we're not really being treated with the same type of respect that we feel we deserve. There's also, so that there's very much that, but also like I didn't quite say it, but like a bit earlier in like the 70s and 80s, like the Soviet scientists were very quick to point to things like that black hole theory, which, you know, I mean, that was in Nature, but it was like a little like letter in Nature, and be like, the American theory of the black hole is the most ridiculous theory ever to come out about Tunguska. You know what I mean? Like they were very quick to do that. So there were a lot of tensions there. I'm not sure about how the speculation and observation, how to quite move that back together. But, so I'll just stop there. We can talk.
Yeah. I came in from the other section, so I was part of the work discussing Tom Seaver's activity. Quite fascinating to me, and I was aware of it at the time. And there's a little that comment really. There's a aspect of how do things happen. We're talking history. This was done, that was done. Well, how was it that this happened? And maybe that was the best before I got in. But Tom Seaver recognized some technology and went out and found a way to use it. Part of what's going through my mind is how individuals matter. And Shelby Tilford, who was talked about yesterday, who was head of the Earth Science program, did a great evolution with that. Shelby funded that work out of his discretionary funds. Okay, it wasn't relevant to our mission. Okay, you know, it just, but he had some discretionary funds, which means nobody's looking, and so he funded that. Now, a curious aspect of that is I was at NASA headquarters at that time running what we called land processes program, and that should have come under my domain. Well, I will tell you, as fascinating as it is, I wouldn't have funded it. Okay. And the reason is what was my mandate, what was my responsibility. And we were trying to build a program doing certain kinds of things, bringing what I talked about yesterday, biology and meteorology into the system. So I would have looked at that and said, gee, that's fascinating. Too bad. See you, Tom. Yeah, and so this is the programmatic side. And then here's the human side. And Shelby had more money than me too. And he said, great, I'll do it. And I just think that's just wonderful that it happened. And if Shelby had given me more money, maybe I would have done it.
And I'll just comment really quickly on your remark. I think that goes to show the importance of kind of interdisciplinary work, even if there's no specific mandate or outcome that we have in mind. The funding of Tom Seaver is actually what I don't think you were here for my presentation, but I talked about how the Foundations of Surveyor, which is another NASA program, came out of the collaboration between Tom Seaver and the work that he was doing in archaeology and environmental science. So, it gave birth to something that was, outside of archaeology.
Yeah, yeah, that's great.
Yeah, Andrew, and then I think we'll go by rows back.
Yeah, I had a question for Kelsey with Surveyor. So your presentation was a lot about the distribution of data, but in terms of, and I may have just missed this, in terms of collection of data, what are the different satellite systems used in the Surveyor program? Is that collected at the request, or is it collected automatically and then distributed upon request? Could you talk about demand?
Sure. So, I mentioned that initially Surveyor was kind of conceptualized as this one-stop shop for geospatial data. And so in that phase, it was, let's work with our partners in the region. There's a specific need for data. Let's try and get them that data through whatever means we can, whether that means, Landsat data through NASA, which at the time was not openly available. So you had to kind of either purchase it or have access through NASA, or purchasing very high resolution data. With the advent of kind of open science and NASA's open data policies, we no longer had to do that. Everyone can access NASA data now. So the types of data that our partners are able to use, or that we're able to use in kind of co-development, the service is vast. So we use everything from synthetic aperture radar, we use high resolution imagery from Planet, we use Landsat is probably the most common product that we use.
So I wanted to come back to the archaeology conversation because I chatted with Mike Freilich on the side. There was this ethics question about that work. And it goes back to the geoprecision with which you're identifying those sites, and then the Raiders of the Lost Ark 7 comes along and takes everything we just found. And so I just was curious how that was fitting in the work now today. Becoming that was a limitation in funding, but obviously we're still funding. So is that ethics issue of the privacy or the protection of the sites? I guess maybe it's to you online as well as you, Kelsey, from your perspective. Are we dealing with that? How are we dealing with that issue?
Let me just re-articulate that so that Tim can hear it. There's a question about the ethics of these sort of very high resolution geospatial data products in terms of what can then be done at those sites by various types of actors. Raiders of the Lost Ark was brought up. And so I guess the question more generally is thinking about those ethics. Is that an ongoing conversation?
It is. It's an ongoing conversation from two perspectives, and this kind of gets back to the question about the paleo data as well in some respects, because the LiDAR is starting to, and probably should have happened fast enough, and I'll try to do this in as few words possible. So yes, the ethical questions are real. The LiDAR data really needs to change our practice, the way in which we practice archaeology, and I think conservation as well. So what I see are two separate kind of ethical questions that have emerged. One has been open data and open science. From a perspective of a lot of archaeological work is by its nature almost like private data sets in some respects. And so this kind of confronts the reality of one person gets a permit, does work at a site, they conceivably, or at least in practice, maintain those data. There are requirements to release these data after certain points in time, and some of my colleagues are being very active about it, in part because I think we're recognizing that what's being shown from these places, once they're documented and understood, it's better to manage and conserve them. That the exact opposite is true about archaeological information. The last thing you want to do is not, the more that we use and apply these data, the more known these places are. And then locally, they're more curated, conserved. But we need to do a much more effective job on an international research basis, is to combine with international researchers on site and in location to help develop that capacity and the infrastructure for those very same data to then be used and distributed in the home countries. And so I think that there's a number of more complex ethical questions that have emerged, and we are recognizing, and I would be curious, anybody else in there has a different perspective, but at least from my perspective, the awareness of this history now is actually going to do a better job of preserving it than it would in providing, say, a map for looters to come take advantage of it. Most of the sites we're working at today, and this is the horrible experience that we have already been looted. They were looted many years ago before there were regulations in place to protect and conserve those sites. Today, there are examples. I'm not going to say that it's not, but it's easier to track and manage. And I think as more of these data are made more publicly available, you'll see even less looting than you would previously. So,
Kelsey, we touched on this in the panel a bit last night about like what happens when you map resources. And Megan Black has this great article, and it's part of a book. I think the book is called The Global Interior. The article is Interiors, Exterior in Diplomatic History. She essentially tracks the IGY program, or not the IGY, the 0.4 program, and shows that when you map stuff, people come and apply capital to develop it, and it's often at the expense of the host nation. I'm wondering about, this is what we talked about a little bit last night, about the ethics of Observer, based on Nancy's question. Like, what are the ethical conversations that NASA's having?
Yeah, so great question. I think that what it comes down to for us at Surveyor is we're always operating under the umbrella of the organizations that we work with in country. So that's kind of part of this being demand-driven work. It's not like we're coming in and saying, oh, we have this idea, or oh, we need this data to improve some other model that someone else is using. That's not how it really works. It's more like, you know, they have a problem, they have an issue. We collaborate on how we think remote sensing might be able to solve the problem, and then they really have ownership and take leadership of that process. So I think it's a little bit different approach, but you know, certainly we're always concerned or thinking about, you know, what are the unintended consequences of some of these projects. So yeah.
Can I add something? Maybe we talk about the illegal mining projects in West Africa,
Right.
And Tanzania. Could you just
Right.
what we're doing there?
So we have, I'll talk about Amazonia specifically. So we have a service in the Amazon that's using synthetic aperture radar to map illegal gold mining in the Amazon. And basically we're partnering with nonprofits who are then providing this information to authorities so that they can then go and police the areas, because the Amazon and the Peruvian Amazon specifically, it's a very vast region. It's very difficult to access certain parts of it. So, you know, we work with them to help provide more specific information to help them do their jobs. But again, it's, you know, we're supporting local institutions that are already in existence, that have their own mandates, that have their own objectives, trying not to bring in our perspective too much.
This question, back row, and then we'll go to Tim, go ahead. Sorry, thank you.
No, I just wanted to have one very practical example, because I think Kelsey kind of spurred my imagination or my thinking about what's been up to. So that some of the data that we're using is really interesting because we can track looting. We could track local looting. And so there's one site, Benemérito de las Americas, that our postdoctoral colleague is working at. And the G-Light the NASA G-Light mapped a portion of the site in 2013. We went back with our drone-based LiDAR and mapped it twice. And in 2018, and then in it must have been 2018, 2019. And the first, we were able to show changes. We actually were able to monitor the site, and there was some damage to the site in that 5-year period. And what was great about it was we brought it to the landowners, the ejido, and we're able to show them and quantify, this is happening to this beautiful, wonderful resource that you have. And they took efforts locally to start managing and maintaining the site better. So I just wanted to offer one practical example. Sorry to interrupt the question.
That's great. Thanks, Tim. Yeah.
Hi, I'm Steve Garber from the office. I have one quick question for Kelsey, and if there's time, one quick question for Hayne. But they're totally separate. So, Kelsey, you mentioned at the beginning that Bangladesh has the highest rate of lightning strikes.
Deaths due to lightning strikes, yeah.
Yeah. Why is that?
So I think it's a combination of two things. One, just the climatic patterns, the type of weather that they get, the type of storms, the intensity of those storms. But two is that people are outside, they're farming, they're doing this work. So they're not necessarily taking precautions or know to take precautions when these types of storms arise. And so that was one of the that was the purpose of this service, was to provide that information so that people can take action earlier to avoid that kind of event.
You want to ask Andy the question too? That'd be good.
Thank you. Andy, I like the Sherpa analogy about Russians guiding foreign nationals to the site. And I was just wondering if actually that 2018 where was that held, and where people from NASA go out to the field?
I'm forgetting if it was Arizona or New Mexico, one of the two.
But it wasn't.
It was here. It was the U.S. And there were some Russian scientists involved, but they were mostly Russian scientists with institutional affiliations in the U.S., maybe working with like some at the Academy of Sciences. There were other Russian conferences that year, and I think if I'm recalling the MedSoc, the Meteorological Society's conference in Moscow that year. But the NASA conference, I mean, they were pretty far removed from the field work stuff.
And what's your sense of over a century of labor? I don't know, your personal opinion, what's the value of going into the field still?
Yeah, I mean, right now I'm not sure. I mean, there's like historical value, there's cultural value. I mean, I do think like it's hard to, if we're talking purely about like solving what happened there, right? Some of that field work has not necessarily paid off, but it could. I mean, they were, there was this Lake Cheka that they were looking for meteoritic material in, and some Russian scientists showed actually this been around too long. It's possible to be, if not, it moved to this other lake, Lake Zapovedny, and there's some signs that maybe they'll find some. So there's still possibility of the continued on-site field work actually giving us a smoking gun of meteoritic material from 1908. But I mean, there's a huge cultural value that this place had. I mean, was sometimes called an island of freedom. There's just in terms of a place for sort of a different type of Soviet society from the 60s onward. I think that shouldn't be totally overlooked either. Just like the cultural value of that, even if it wasn't necessarily scientific value.
Thank you for your patience.
Jonathan Cooper from Texas A&M. I just what Kelsey mentioned at the beginning that this is a unique program, and one of my and I guess not my major. How did that happen? Is this a model that could or should be used in other parts of NASA? And if so, how would you replicate it? And I also know that
in your pictures, you noted here are the administrators.
Mhm.
You know,
Yes. So definitely, so when Severe was started, it was a unique program at NASA. But I think that, now we have the entire applied sciences program, we have capacity building program, which is the project that Nancy manages. So there is a lot more kind of engagement in this kind of using NASA data and NASA Earth observations to make decisions at a more local scale. So, but administrative support is very important to kind of push that ball forward. And maybe Nancy has something that she wants to add to that.
Sure, I'll add a little bit, if you don't mind.
Please.
Yeah, so the value of complementary resource and mandate between USAID and NASA, in this particular case, has been the sweet sauce that has allowed Severe to go. If you look at USAID projects, they're usually 3, 4, 5 years done, right? So just like us, when we fund a grant, 3 years, if you're lucky to get another grant, that's usually the same thing. And so the value of long-term relationships is just so important, that program. And I think USAID sees that too, as well as NASA. It's actually a pittance. USAID $20 bill, I call it a $20 bill, right? Our $20 bill is $100K a year, right? For a grant. Their $20 bill is $5 million, right? So they have different size $20 bills. So it's just important to note that Severe is actually pretty tiny budget, but it's got this long-term history. Coming soon to a place near you, I hope we will have a newly signed MOU, our third round on our MOU between NASA. And the first one was because only for Severe. The second one was Severe went, oh, we should do a little bit more here, there, and everywhere. This one is super exciting. I guess I'm giving you a precursor. It hasn't come out yet. I'm trying to get the darn administrators to sign it. The administrators, their attention. But the cool thing is that we've got different parts of NASA and USA thinking much more broadly about leveraging our unique mandates and our resources. So I'm hopeful for bigger things. Severe, I think, will always be considered a really important program because of this longevity of the relationship. But I have other folks wanting to dive into Severe. Hey, I need some ground-based data, extractive scientists. Don't want to do the co-development, right? We have that as we. So, but how do you take that intent of better collaboration and scale the co-development model to something we want?
And that brings up a really interesting point. I talk a lot about co-development in terms of us working with our partners in the regions, but we also do co-development with the US-based scientists that we work with to kind of, in this extractive science or, parachute science type thing. So it kind of works both ways. And that's another really exciting component of what the work that Severe does.
Before we take this conversation to the coffee urns, I want to just say thank you to our panelists. And thank you to all for being here for this wonderful panel. Oh, that article. So are you thinking about? Okay, so global interior. We felt that the Department of Interior as a foreign policy body, but particularly following this. And I would say the article, articles in diplomatic history is called Interiors Exterior. Backstory on I don't know, 0.4 program in particular, but generalizable because of what happens in the US, things like support thing or sharing, and it turns out that's really good. For this year, For you all, I think you was on the history of US He goes into the carbon interiors, like, interest in and purview over space research, which is so weird. Because the carbon interior, right? Like, I mean, the super problematic part of it is the extent to which there's continuity between like the dispossession of the carbon interior prostitutes in the 19th century to steal land from Native Americans and their strategies in the 1950s. Yeah, I mean, it was so good. It's just so interesting. The Air Force incursions into what you can airspace. They have these agreements about like where you can fly and what you can do. They're doing all the sonic boom testing now. And it's right by an Air Force base. It happens to be sited there because there's like the myth of free land that still is like pervading US policymaking in the middle of the century. Megan Black. And the article is called Interior Detector, and the book is called
Hello, testing.
Yep, we can hear you. We're just going to get started in
Okay.
about 5 minutes or so.
Okay, thank you.
Hello?
Right, I think we should probably go ahead and get started. For a couple minutes over here, I want to thank you all for coming today. I appreciate it. We're really excited to be here for climate change, weather, and atmospheres. My name is Mike Hankins. I'm a curator at the Smithsonian National Air and Space Museum, and I'm thrilled to be here to welcome you guys. And we have a lot of presentations that are virtual today. So we've got a couple of pre-recorded videos, and then we will have some Q&A with everybody as well. Is everything okay? Okay, good. Good, so I'm gonna go ahead and introduce some folks coming up first, and then I'll introduce everybody kind of in between as we go through, and then we'll do a Q&A at the end and have a good discussion, I'm sure. All right, so first up, we have Christopher Hayne from the NASA Marshall Space Flight Center. Dr. Christopher Hayne is the project scientist for NASA's Short-Term Prediction Research and Transition, or SPORT, Center at Marshall Space Flight Center. SPORT focuses on transitioning unique NASA research applications and capabilities for our operational stakeholders to improve their decision-making. So I will hopefully figure out how this works and see Dr. Hayne's presentation here.
Hi, my name is Christopher Hayne, and I am the project lead for the Short-Term Prediction Research and Transition Center, or SPORT, here at Marshall Space Flight Center in Huntsville, Alabama. I'm sorry I'm not able to attend the symposium, but I wanted to give you a brief overview of our project, and then I'll be around for the questions and answer segment afterwards. Really what SPORT is focused on, our tagline is rapidly transitioning user-driven science needs into applications. So to kind of give you a historical perspective of the SPORT project, SPORT was established back in 2002, so we've been around for almost 2 decades now. And SPORT was really started with a focus on transitioning unique NASA satellite observations and research capabilities to operational end users and decision makers, really to try to improve short-term operational weather forecasting and decision support. With that focus, we really worked initially a lot with Noaa and the National Weather Service to look at forecast challenges that their forecasters experienced on a daily basis, and tried to find either NASA solutions, either through Earth observing data or through model capabilities to really improve that decision-making process. The paradigm that we really operate under is shown in the figure there on the right. What's really unique about our process is that we do co-development with our stakeholders. We don't do science in a vacuum. We don't develop something and then try to market or sell that to a decision maker. Most of the science and solutions that we develop are developed based on a consultation and feedback that we get from our operational stakeholder by bringing them in early in the process. So everything we develop here at SPORT starts with a conversation, sitting down with a forecaster, sitting down with a decision maker, and understanding what their forecast challenge or problem is. Then we really do try to address that through finding either a research capability within the community or developing something here within our SPORT project. So when we do develop that solution, we then, rather than just handing that solution off to the stakeholder and then moving on, we stay with them throughout the process. We provide training data, we provide decision support training in the sense that we work with them to get the new tool or capability into their decision support system. We do targeted product assessments. We do periods of time where we work directly with the stakeholder to understand how they're using the new product or capability in their decision making. And then we kind of get to an end point where we have to ask ourselves, is the problem addressed? Usually the answer to that is no, we haven't fully addressed the challenge that we set out do. And we call this really that operations to research feedback, where we find out what worked and what didn't work in operations, and then we take that back to the research side of the project and further develop that solution to address those new challenges. So we stay within this iterative loop until we're able to answer that problem, is the problem addressed question, and then we're able to transition that capability for a sustained use in operations. And over the last 20 years, we have successfully transitioned over 40 different satellite data sets and research capabilities to our operational stakeholders. Naturally, the project also over the last 2 decades has evolved. While NOAA and the National Weather Service are still our primary stakeholders, the concept of doing research operations and developing applications in a co-development framework is applicable to lots of other agencies, both at the national level, the regional level, and the local level, from everything from weather forecasting to drought monitoring to air quality and human health to disaster response to wildfire. There's lots of different areas where the paradigm now has been applied. And as you see there on the left, we have a number of different research areas that we focus on in SPORT, everything from tropical meteorology to atmospheric remote sensing, lightning convection, air quality, human health, land surface remote sensing, and then machine learning. And then at the bottom there, you see some of our core transition activities, kind of the social science component of our project, focusing on training, doing the product assessments, and naturally, when we create a new product, making sure that we produce that product in a near real-time sense so that it's available to our operational decision makers. So from a historical perspective, I'm going to go over some of what I like to think of our sport's greatest hits, some of our biggest accomplishments over the last 2 decades of our project. This was a big one, essentially pioneering the use of multispectral satellite imagery from geostationary sensors. Geostationary sensors essentially look at the same spot of the Earth, providing high temporal and spatial resolution information for operational decision makers, especially within the National Weather Service. As we moved in the last about 5 or 6 years ago, NOAA moved to their next generation of geostationary sensors, and this provided a number of new capabilities that forecasters had to be prepared for. We were able to prepare them for these new capabilities by using some of NASA's low Earth orbit satellites that provided some of the information that they were going to see from these new geostationary sensors before those geostationary sensors were in space. So essentially providing what the data would look like. And then some of those examples are this idea of RGB or red, green, blue imagery, which is a way of combining different sets or different wavelengths and spectral information to produce value-added products. For example, up on the top there, you see our air mass RGB, and you see that brown shading is warm, dry descending air, enhancing the strength of that cyclone. And then at the bottom, you see a microphysics RGB, which clearly allows forecasters to clearly see the difference between fog and low clouds compared to high clouds by looking at, you see in that light blue color in the circle. Another area, obviously relevant to when I'm recording this today, as Hurricane Ian is making landfall in South Florida, is our research with tropical meteorology and our ongoing collaboration with NOAA and the National Hurricane Center. What SPORT really is focusing on is finding new, unique ways to develop research to address some of the things that are still outstanding science questions within the tropical meteorology field. While track forecasts for hurricanes have improved over the last decades, we haven't seen the same increase in forecasting, especially rapid intensification. For example, Hurricane Ian today once again rapidly intensified as it was making landfall. And one of the things we're looking at is the use of lightning data within the inner core of a hurricane to be indicative of rapid intensification. We're able to use observations from the geostationary lightning mapper to really understand both how often lightning is occurring and then how bright and how optically bright the lightning is and how large the flashes are. And what we're finding is when we have these large flashes in the inner core of a hurricane, it is more indicative of intensification than if you see those in the outer part of the hurricane, where they can be driven by different physical processes. Another project that SPORT has really pioneered is the use of land surface modeling. We run a near real-time land surface model that provides essentially decision support and situational awareness with fields of soil moisture and soil temperature. This is really important for looking at forecasting flash flood risk in the National Weather Service, but also for drought on the dry continuum. So being able to track how dry the soil moisture is and what some of the downstream impacts of drought is. And we do this, like I said, in a near real-time sense, and provide this to our operational decision makers. And we've really seen a lot of growth in this field, in the drought monitoring field, as our Sport Liz system is routinely used in the weekly drawing of the U.S. Drought Monitor map. Another really cool use of satellite data. So a lot of our National Weather Service partners, after, say, a tornado occurs, have to go out into the field and survey the damage, survey the track, so that can be documented for a number of reasons. Through the use of high-resolution commercial satellite data, we've given them the ability to take essentially a portable tool that has this high-resolution information, so they can actually see some of the damage track from space. I mean, usually they're on the ground trying to survey the damage, and this tool really gives them, an eye in the sky and an ability to see more clearly when the tornado started and when the tornado ended, and how wide the damage track was, really lessening the amount of time that the forecasters have to stay on the ground doing an actual on-the-ground survey. And then finally, I want to end with some of our work with lightning safety. Obviously, lightning is a hazard and a risk for outdoor events, and providing better situational awareness tools for decision support when there's large sporting events, large concerts, when you have a lot of people outside. A lot of times you'll see on the news people in the stands with lightning in the background, and that's what we're really trying to avoid. While we've been able to avoid a large event where people are struck, it's really prudent for forecasters to be able to have the time to get people to safety. So we've developed a number of products that address this. The first one you see there is the sports stoplight product. And this is really just giving a sense of what's happening and what has occurred in the last 30 minutes. So you see that green, yellow, and red shading color ramp. The red being that there was lightning occurred at that pixel in the last 10 minutes, all the way to green where there was lightning occurred in the last 20 to 30 minutes. So this kind of gives forecasters some view into where lightning had occurred. What we're really moving into now is trying to predict when lightning is going to occur in the next 15 to 20 minutes, so that you give those decision support forecasters a little bit more lead time in getting people to safety. And we're doing that through machine learning and trying to understand the physics of how lightning occur so that we're able to better predict. So I will end there, and I will take any questions in the Q&A section. Thank you.
Yes. Thank you. And hopefully I can figure out how to do this. Okay. Thank you to Dr. Hayne. Next up, we have James Garman. Jim Garman is the chief scientist of NASA's Goddard Space Flight Center and principal investigator of NASA's Da Vinci mission to Venus and her atmosphere, launching in June of 2029. His NASA career as an Earth and planetary scientist spans nearly 38 years, during which time he served as PI on the first orbital flight of an analog waveform laser altimeter in the Space Shuttle Endeavour in January of 1996, as well as NASA chief scientist. He's a graduate of Brown and Stanford universities and has received 3 presidential rank awards for his work as a NASA scientist. So let's go now.
Lasers in space. This is the history of laser altimetry, a campaign to measure the shape of the Earth's surface at human scale, at people scales. These are the scales that matter as we monitor our environment, understand what climate is telling us, look at the records, watch the land and ice and treescapes evolve in the place we live. That history began here at Goddard and with a partnership between scientists and engineers way back in the 80s, putting together the technology to measure the landscape at the scales we walk on. The same techniques we can now use to explore the moon as we prepare the way for Artemis and the women to go back. This story is one that's unfinished. It's a masterpiece that's becoming in focus. We mapped all of Mars with the laser altimeter MOLA that gave us the ability to precision land large rovers and someday women and men. We mapped the ice sheets of the Earth as we're doing now with ISAT-2. We mapped the treescapes of Earth in 3D for the biomass and the carbon cycle with JEDI. And we started those explorations here at Goddard with the Space Shuttle Endeavour with the shuttle laser altimeter. Against many challenges, this instrument showed us the way. And the history is really one of engineering and science coming together to explore our own land, our own planet, the history of environments and climates, but then applying them forward to map asteroids, the moon, Mars, Mercury, someday Europa, even worlds like Titan. This story, again, is one that's unfinished, but it's our story, measuring the unmeasurable, bringing it into human scales, and allowing us to predict the future. Laser altimetry and lasers in space, it's a story undone, and we can't wait to continue.
Oh, whoops. Okay. Moving on. And just let me ask, because I can't really see in the Zoom here, is Jim here? I think yes. Okay.
Yeah, I'm here.
Excellent. Would you like to add anything to that now, or do you want to wait till the Q&A? Or
Well, I could add just one comment, and I intended the video to be a short encapsulation of the much longer story in the spirit of the history for this conference. But can everyone see me? I don't know. I'm murky here, can't tell, but hopefully you can, Mike. So the big message that I had that maybe is lost in a very short video is, you know, the history of NASA and climate research is one of establishing boundary conditions. And those boundary conditions include the shape of the land and at scales that aren't always very accessible. And today we take it for granted we can measure these things with drones in our backyards and other methods. And they weren't even invented in the mid 80s when we started some of these great Earth science endeavors that led to shuttle imaging radars and the shuttle radar topography mission, as well as these LiDARs that I was speaking about. And so today the capabilities are extraordinary. I mean, literally, as we speak, JEDI can measure the dynamics of tropical forests as it flies over them. And if it can be sustained, we'll be able to bridge the gap of this period of climate variability. I said the same with ice sheets. And so we've come a long way in the last 40 years, and there's much more that can be done. And these techniques are evolving rapidly thanks to engineering. And as science and society come together, they make it possible to do these things. And while I'm sitting here with a backdrop that is not Earth, that is Venus, it reminds us of how climate variation and evolution can run a little against what we'd like it to be. And where we're going with Da Vinci is to try to understand a world that has gone into a climate extreme state and compare that to Earth. So this state of understanding topography is very important. It's come dramatically, and NASA will launch a new mission that will explore aspects of it in 2023 called NISAR. So this is again a story that's unfinished, but that will get better and better. So that's all I wanted to add, Mike. Thank you for listening.
all right. Thank you. Let's go ahead and move on to our third presentation here. This is from Gemma Sorak Claveras, who is Associate Professor at the Institute for the History of Science at the Autonomous University of Barcelona, where she investigates the co-production of measurements, data, models, information, and knowledge flows generated with remote sensing satellites and environmental discourses, practices, and policies. I'll go ahead and play this presentation.
Hello, I am Gemma, and this is my contribution to the session. What are you seeing in this image is a hurricane seen from a satellite. We are all familiar with this sort of images, right? More generally, our current understanding of what the environment is relies enormously on data provided with remote sensing satellites orbiting the Earth. In this talk, I want to give some clues about what are the origins of the relationship between data and the environment, satellite data and the environment? How did this relationship come about? And what are its political, epistemic, and social consequences? I will first refer to what I like to call the digital environment as a conceptual frame, also a bit of provocation. Then I will give a bit of theoretical and empirical context that justifies it. And finally, I will introduce a research project that aims to deal with these questions. So my provocation begins by claiming that we are living today in what I call the digital environment. It refers to the idea that our experience of the environment would not exist without data, today digital data. Now, in many cases, data about the environment can be treated as synonymous of the environment itself, especially for policy purposes. So the digital environment can overlap, and can influence the physical environment. Another characteristic of the digital environment is that it has an implicit perspective of planetary management, how to solve the problem of how to live on Earth today, but also in the future. Prediction is central, and the assumption is that the environment can be quantified and thus predicted and thus managed. And this emphasis on prediction is important because it implies a very specific methodology, numerical models. We must produce and distribute a very specific form of data that is useful for numerical modeling. After Paul Edwards, many of us are well aware about how data and models are imbricated. So this is a very particular way of understanding what the environment is. And the question is, how did we come to that? In this talk in particular, I will focus on the climate, the digital climate, as a particular part of the digital environment. So from environmental history, we know that what we understand as climate changes throughout time. We are interested today in the idea of climate as both scientific object and political entity of global scope. And by global, I mean not only in geographical terms, but also because it shall be governed by international institutions. And it is also global in the sense that absolutely all spheres of our daily lives have been colonized by climate-related sensibilities. Nutrition, health, sports, transport, industry, education, clothing, leisure. So climate history tells us that this very particular idea of climate gained impetus, especially in the 80s and 90s, the same period in which Earth-orbiting satellites proliferated and began enabling the compilation of unprecedented vast amounts of data about the oceans, the atmosphere, and the land surfaces. In this period, climate ideas transform from being the research topic of a few scientific specialists to become also a matter of international diplomacy. Historians of technology have illustrated how technology influences these perceptions of climate. One of my favorite ways of framing this is using the concept of environing technology by Nina Worms and Sverker Sorlén. Look at this picture. Strange. There is not a single cloud. This image is produced with data from the sensor MODIS inside of one of NASA's satellites, a radiometer unable to detect clouds. The choice of the sensor we put inside a satellite, its spatial resolution, the times per day it passes over the same region, its materiality, conditions what becomes measurable, visible to our senses, what comes into an existence, what kind of climate do we experience. What counts as data also changes over time. Take climate numerical models. Since the 80s, climate scientists have been using not only instrument readings, but also simulation models outputs as observational data with the same epistemological status as observational data. At the same time, satellite data are not just objects that can be collected if one has the right tool. Instead, satellite data are cultural artifacts, profoundly marked by the highly localized scientific practices, institutional settings, and socio-technical arrangements from which they emerge. I like very much the expression becoming data. That precisely emphasizes the organizational, material, financial, legal, institutional, ideological configurations involved in producing, circulating, and making use of data. For example, since the mid-2000s, private companies are emerging that claim that they can produce and distribute weather satellite data with their own satellites, hundreds of them, faster and cheaper than governmental satellites such as those belonging to Noaa or EUMETSAT. Letting the private sector into a field that has so far exclusively carried out by governmental agencies is a political choice, which raises a lot of debates, also of moral character. Paul Edwards says, imagine that information about a devastating hurricane is only available to those able to pay for it. My point here is that in this transition from a view where weather data and the weather itself are considered as a public good to one where they are subject to private profit, the system of data production is central. Another example. Along the 80s and 90s, NASA created and promoted a system to distribute environmental data, which I like to describe as a factory because it was a system at the service of a commodity, the data. And it was adopted by most of the organizations that produce satellite data today. According to this system, you can see it in the image, data was organized following a series of levels, in principle technical, depending on the data processing techniques, on the type of algorithms of correction calibration procedures, but a whole social structure, hierarchical, was established around it, and it determined who had the privilege to access the data and how this data was supposed to be used. So this factory of data implied a separation between those who produce the data and those who use them, and those who curate them in between, and also those who market them and sell them. I like to approach it in terms of power relations and inequalities. Like example, environmental history tells us that tropical forests have been the object of conservation policies at least since the 17th century. Here we have a typical representation of such forests in Malaysia. So when using satellite data, one way to depict tropical forests is that one. There are various juridical devices that are based in this type of data, so that enumerate trees in a forest in that way, and that are used to transform the tropical trees into carbon stocks to be inserted in the global market. This illustrates that the type of data users we are contributes to define our understanding of climate. All this background allows to see that satellite data form the nexus of various economic, diplomatic, regulatory, scientific, and communication interests. Their history is necessary to challenge existing, dominant, and simplistic accounts of climate as a merely technological problem that can be solved exclusively using technology, which are dangerous because they imply that the obstacles to climate action are epistemic rather than political. And our job as historians is precisely to get an understanding of how this narrative came into being. So I argue that we must not take satellite data for granted, as if they are not historically situated, unquestionable, not subjected to scientific or political debate. They are, because their production, circulation, and use involves a whole political, economic, juridical, diplomatic infrastructure. Understanding its origins, practices, and dynamics and configurations helps illuminate what messages are conveyed, how are they negotiated, by whom, and how do they reach different types of audiences. It helps reveal imbalances in the distribution of data, the international legal infrastructure that supports this uneven data distribution, and how all these interactions have shaped the kind of climate discourses, policies, and practices that we have inherited today, which I have suggested to frame under the umbrella of the digital climate. This is what I'll be doing during the next 5 years. We will investigate this history, and we'll do so by researching different branches of history that are involved in the production, circulation, and use of satellite data, science and technology, economy and finances, law and regulation, communication, and diplomacy. We want to understand how their historical interrelations contributed to develop certain perceptions about climate. We will focus the analysis on the data generated with these 3 satellite programs developed during the 80s and 90s in Europe, and this will allow us to find out how satellite data and our current understanding of climate co-evolved, influenced each other. So thank you for listening. Please write to me if you have questions or comments. I'll be very, very happy to discuss them. Thank you.
Hope all of our Zoom participants can hear the applause that they're generating. Timothy Lang is up next. Please welcome Timothy Lang from the NASA Marshall Space Flight Center. Timothy Lang is a lead research aerospace technologist at NASA Marshall Space Flight Center and is the mission scientist for the International Space Station Lightning Imaging Sensor. He's been studying thunderstorms and lightning for over 25 years, the last 10 of which have been at NASA. Do you have slides here? Yes. Let's see if I can hold them up here.
All right, well, thanks for listening to me today. I'm talking about the history of NASA global lightning observations. And I want to acknowledge all the people who helped with this. They kind of make this, made these observations possible, as well as made this talk possible. I say NASA global lightning observations. I want to acknowledge up front that there are other federal agencies, other countries that have also made global lightning observations, including from space. And so I'm not going to talk so much about those, but I'm happy to answer questions about them in the Q&A. One thing we want to do with lightning is, we need to understand, like, why does NASA study lightning from space? So obviously lightning kills people and breaks things. In particular, back in 1969, I believe it was the Apollo 12 was struck by lightning when it was on the ground, on the launch pad. And this kind of raised awareness at NASA that, well, we maybe need to understand lightning observations and why lightning is occurring and how do we protect ourselves better from lightning. Lightning is also related to processes within clouds, and that has implications for, whether there's lightning and how much lightning and what that lightning looks like are all functions of these processes in the clouds. And so we need to understand lightning gives us information about what's going on there. Lightning also produces trace gases that are important for global biogeochemical cycles and the Earth's climate. In particular, the biggest one of those is lightning nitrogen oxides. Lightning also doesn't just stay in the troposphere. Of course, famously, we now know that lightning can go above thunderstorms, and also things can occur in the mesosphere like sprites and halos that are occurring above the troposphere, and even lightning can impact things like the radiation belts of the Earth, and lightning occurs on other planets. So these are all reasons why lightning is a subject of NASA's focus. Now, when the first astronauts went up and the first satellites went up that took some rudimentary pictures of the Earth, they saw lightning right away. I'm not going to talk so much about that. What I'm going to talk about here is more efforts to kind of try to get at more quantitative information about lightning from space. And so this actually started very early in the shuttle program. In fact, like STS-2, I believe they had this started out. And what they did is they give like film cameras to the astronauts, and when they had a spare moment, can you take some picture or take some video or film of lightning storms, especially at night, and even during the daytime, take pictures of convective clouds. And later, after the Challenger disaster, and when the shuttle's flights sort of resumed, we changed it and started putting on, instead of tasking astronauts for this, we would actually have sort of remotely operated video cameras that were in the payload bay of a shuttle, and they would take pictures and video of lightning. And this enabled a lot of rudimentary photogrammetry and other quantitative analysis. You see an example of this here, where you have you can see in successive frames sort of the development of a lightning flash from above, and different areas of the cloud are illuminated at different times. And so that's telling us something about the structure of the flash from space. The other thing is when sprites were first actually scientifically recorded back in 1989 from the ground on video. People at NASA went back to these shuttle videos, and lo and behold, we were seeing them. We just didn't notice them before. So that was very interesting. Then what came next was the optical transient detector. And this was an instrument that was developed at Marshall and with its partners like at University of Alabama, Huntsville, and elsewhere. Is essentially the first spaceborne global lightning mapper. It was on this Microlab 1 satellite. And the key here, if you take a video camera and you point it at a cloud, it's hard to see lightning during the day. And so the way to do this is we would look at just a very, very narrow band filter at 777 nanometers. That's in the near infrared. And we'd use that. That signal is actually fairly strong relative to the background signal from the sun. And so this is a way to detect lightning during both day and night. And so we would use a high-speed camera, essentially, to look at this. And you're not really saving all those frames. You're just looking at differences between the frames as you go along. And that's how you detect the lightning. And the way this was quite successful. And you were able to essentially map lightning globally with that first image there, with like several years of worth of data from it. So OTD was kind of a proving concept, or concept proving proving ground for the lightning imaging sensor. This was an instrument, I think people were talking about the EOS missions. It was originally selected to fly in the EOS. It did not make it onto that first set of satellites. Instead, it got put onto this tropical rainfall measuring mission. And the reason for that is that this had some very complementary instruments: microwave radar, microwave radiometer, and lightning observations and microwave observations are sort of two great tastes that taste great together. And this is the thing that kind of helps really enable storm science from space. And so that was a very powerful set of tools. Liz was operational for 17 years on TRIM. And so that's actually also enabled a very ultra high resolution climatology of tropical lightning and allowed us to figure out where are these major hotspots, places like Lake Maracaibo in Venezuela and elsewhere. So that was very important. So with a lot of missions, you build flight spares. And we had a flight spare for Liz that we never needed because TRIM was so successful. So it just sat in storage. And so Rich Blakesley at NASA Marshall worked tirelessly to find a ride for this. And we finally were able to get a ride for it on the Space Test Program. And this is a DoD program that will allow ride sharing to test new concepts. And it's become actually in recent years very important for sort of these orphan instruments that just kind of don't have a ride yet, don't have a home, because NASA has more instruments than it has satellites. And so this has been a powerful way an effective way to get more NASA observations into space. Rich described an interesting experience where he would find, working hard to like get this into space and confronting like a program manager right at a conference after he had just given a talk, and just going up to the program manager and say, hey, let's look at this slide deck about, why we should put Liz in space again. And so this was all kind of leading up to the geostationary lightning mapper. Now the geostationary lightning mapper, I think Chris Hayne and talked a little bit about this too. This is essentially the Liz OTD concept, but at geostationary orbit. And I want to stress that this was always the dream. Hugh Christian, who is kind of the father of all this, he wrote papers back in the 1980s talking about why we need to put lightning observations and geostationary orbit. And it's simply for that. You have continuous field of view. You're always looking. And so you can map things on the hemisphere. Now, while that was very successful in mapping, of course, over the hemisphere, you would need multiple of these geostationary sensors to map things globally. So along the way, we were able, by staying in low Earth orbit with LIS and OTD, to actually map lightning globally, which you wouldn't have been able to do had you just had one or two of these geostationary instruments. So it's one way where you kind of, by failing to get something to geostationary right away, you were able to actually have another type of success where you got global information. We continue to think in the future. Couple issues with things like GLM and LIS is that when storms get very severe, they have lots of flashes. Those flashes tend to be very dim and they tend to be missed by these mappers from space. And so we're trying to get more information about and detect more of those flashes with this new conceptual mission that we're working on. And also this would be able to, instead of just providing 2D maps of lightning, we could get 3-dimensional maps of lightning, which give us much more information about processes within storms, as well as where the nitrogen oxides are being produced in the cloud. Before I finish, I want to give a quick just shout out to the role of suborbital observations of lightning. They've played a major role at NASA since the 1970s. Flights on the U-2, et cetera. Those are how we kind of figured out why we want to do 777 nanometers. Why did we do that? And how does this instrument, this transient detector, really going to work? And NASA maintains continuous ground networks for lightning to support rocket launches at like Kennedy Space Center, and also validate on-orbit observations of lightning. And then this is my final slide. We've produced this multi-decadal record of global lightning from space, and we're looking to continue this mission in the future. Right now, we can make these very pretty maps that contain like 2+ decades of lightning data within them. But the challenge now is to kind of merge these different instruments and get at these small differences between them, sensitivity, latitude, range, that sort of thing, and try to build a more continuous time series so we can actually investigate climate change and its role in lightnings as a signature of that. So thank you very much.
Okay. Let me get all of our participants here on the screen. I definitely want to thank all of our presenters here. And I hope we can have a good, robust discussion here. There's a lot of really interesting ideas in all of these papers to talk about. So I kind of have some thoughts and a question to maybe kick us off here. And the first, there's a lot happening here with talking about humans and their interactions with the environment and how technology plays a role in mediating all of those, which, and of course, in its own relationship. So we're talking about, how people are relating to technology and vice versa, and then how the people and the technologies they're using are interfacing with the environment, and how the environment is influencing that. So there's a lot of really complicated relationships, I think, that all of these presentations are speaking to. But the thing that I kept thinking about as I was listening to everyone today is, coming from, I'm kind of a cultural historian, so I'm thinking about the institutions that are at play here. And something that all of y'all spoke to was institutional interplay. There's a lot of different organizations that are collaborating with each other, whether they're sharing data or sharing instruments, or even just sharing ideas, and having to navigate those relationships. I was just wondering if each of you could maybe speak to the ways in which those institutional interplays have happened. If you noticed any major changes, were there any major, institutional clashes of culture or ideas about how to use this data or how to use these instruments in the course of your studies? So I'd just be curious what all of you thought, and then we could go to the audience and see. Thank you.
I guess I can start. Within lightning world, there's a lot of different institutions that look at it, and usually it's like 2 or 3 people at each institution that are actually doing the work. or just a small number of people. And so together you build like a community that does lightning research, whether with NASA assets or something else. But typically it's just a few people at each thing. So lightning always has this kind of, redheaded stepchild experience of being like just almost too small to be like to pay attention to. And so like, you're always fighting to like to get that. And so the way you kind of build the strength to build the momentum to make these instruments and actually get them into space is to build those collaborations among a lot of different institutions, foreign institutions, other agencies, federal agencies, other universities. It's very important to be highly, even commercial sector, it's very important to be highly collaborative because there's just not enough within any one institution, there's not enough people to really build the case. So you almost have to collaborate.
I don't know if everyone can hear me, but if I may jump in, Mike, if that's okay.
Please, yes, we can hear you great.
So topography, the shape of the ground, the fuzz on the ground, it's kind of a community-based commodity. And, we live on it, we sail on it in the ocean case. And so it's inherently trans-institutional, I think. And so while the scientific uses involve using it as a boundary condition in models, in measurements of dynamics, the extreme flooding from Hurricane Ian brings to mind the need to have very detailed topography at vertical scales that allow us to predict storm flooding in areas both extreme but also not. And in fact, in our experience with this multi-institutionally, flying on the space shuttle, we made measurements of some of the global very low-lying deltaic regions of planet Earth. And we made those measurements with the shuttle at sub-meter quality for the first time in the 90s, which was, hadn't been done. And it just showed how flat these places were. The Ganges Brahmaputra for 150 kilometers varies by about a foot. So you can imagine a little push of water is going to have a big effect. And that makes the measurements and the use of those measurements just, it's sort of a societal application. And so the other aspect is exploring the aspects of the shape of the surfaces of the Earth and the ice sheets and the oceans at scales that, become discovery potential. And that really brings in other institutions. Sometimes those involve institutions that involve, of course, management of transportation systems, planning for said. And so in the course of NASA working these things, the partnerships have been global, multi-space agency, but also multi-societal. And that brings to mind what Gemma said about, this digital artifactual world we live in, because as we improve our knowledge of the topographic boundary condition we sit on, we learn more. And that's really important when we look at projecting ourselves forward to the moon through Artemis and other programs, but also to the time when we put people on Mars. So the multi-institution aspects go beyond NASA inherently. And in some cases, they also become economically driven, econometrically driven in a sense, because the better you know it, the better you can use it, the better you can build on it. And that ties many organizations, including governmental ones. In the case of topography, U.S. Geological Survey, of course, and other partners. So anyway, just my 1 cent.
Yes, please jump on in.
Can you hear me?
Yes.
Okay. So yes, I think that you made a good point in pointing this institutional interplays that at least I'd like to see them also in terms of, as I said, of power relations, because we have mainly talked today about technical institutions or scientific institutions. But of course, climate or the environment is more than a strictly technical, technological, scientific issue. And then when you include other non-strictly scientific or technical institutions, that like
issues of legislation, data sharing, to establish data sharing rules, or issues about diplomacy or international relations to negotiate this data sharing, for instance, which operate at different scales. Some operate at federal scale, some other at university or local scale, some at international scale. So then when they come into the game and they have different ways of doing, different motivations, different objectives, institutional objectives, then this is still more complex. And I think that examining this, how they interplay is a good or an efficient way to precisely reveal these power relations that are in play. And also, from another perspective, if we look at the chain, if we shall use the term chain of production, circulation, and use of data, those who produce the data have little to do with the majority of us who use the data. So examining the institutions involved in every part of this chain maybe also a very good point to start and to learn a little bit of what the kind of environment we are referring to. That's it.
Yeah, I'll just add that, I think, we've had nothing but really great experiences working with other institutions. I mean, the goal of our project really is to make sure the science and the observations we collect have societal impact, and that other agencies who have to make operational decisions are able to use the data that NASA collects and the models that we develop and the capabilities that we develop. So yeah, I mean, I think it's one thing to do science. We like to say we don't want to do science in a vacuum. So when we develop science here at Sport, we're doing it to address a known challenge or a known problem. And I think we show that that's the best way to make impact. Obviously we get into science because we want to develop things. We want to push the envelope forward. But it's really much more rewarding when your science can actually be used to make somebody's life better, save life, make things more safe, and just better understand this wonderful planet we all live on.
Fantastic. I know we have some questions here.
Martin Collins, Georgetown University. I really am sort of intrigued by, especially the NASA presentations, but it's deeply embedded in what Gemma's doing as well, is how one arrives at deciding on what research objectives they have, right? And this sort of discussion between the applications of these different technologies and programs that have been highlighted here today, how those feed back into when you're dealing with kind of societal issues, especially those attached to climate change, come back in to say we want to design a satellite instrument that does this. Is it deriving from fundamentally, kind of scientific elite perspective that says these are interesting questions, or is it a combination of all these factors that sort of lead to a particular research objective? And the kind of point of orientation for me as a historian is to look back, say, at the early history of NASA, in which the basic science narrative always sort of was at the top of the hierarchy, and applied science kind of trickled down. It sounds like in these programs that set of relationships is fundamentally much more complex than it was characterized 30, 40 years ago.
Yeah, I can speak a little to that. You're right that generally it's the scientific questions that sort of drive these things, and that's really manifested in the decadal survey process, where you have all people write the white papers, and then you have this committee that sort of decides what to make of all, and what are the most important questions. That being said, with this latest set of decadal surveys and the missions that are coming out of them, like AOS and SDC and all these different atmosphere observing system and surface deformation change and all these other missions that are coming out of that, applications have risen in prominence, and you have it's at least considered in the overall mission development. What are the kind of applications? What can we do that the society could benefit from that this mission will provide? So it's becoming more of a thing. I don't know that it's quite at the same level, but it's definitely moved up.
Hey, Mike, this is Jim. I think that's a great question historically, because the cycles of NASA development, as I think the colleague who asked the question, has exactly put the tension he described in perspective. So coming out of the 60s and the first wave of environmental remote sensing by NASA and partners, and into the Apollo era with success beyond planet, the feedback led to a re-examination in NASA in the 70s. I mean, it was often called the roles and missions recalibration, and that led to an entire Earth science application program that Mark Settle ran, that triggered new technologies in space, which had an application but a measurement core. And so the heat capacity mapping mission, extension of the Landsat series with new sensors, the shuttle imaging radar program that flew in the early shuttle. And that was an attempt to bridge that gap in the era before National Academy-driven decadal surveys were part of Earth environmental science or even planetary. Astrophysics were actually doing them very early. And so that evolved in the 80s into the decade of the 90s, when the Earth observing system, which was built around things bigger than just the white papers that go into the decadal surveys now, which are so good, but built into large multi-year studies that compiled the basis for that mission to planet Earth perspective that was first implemented in the 90s, and parts of it continuing today, of course, as was mentioned. So there's cycles of how the applications mix works, and the applied science of value as a commodity in NASA is always part of the decadal surveys. It's even a part of those in astrophysics and planetary, for example, and of course in space weather and earth science. So that's been a part of it. It's just the level of amplification. And so I think what happens is, as we understand more about an environment, we see the fundamental measurements that are missing, sometimes the unmeasurables that we want to measure, but we also see the feedback loops into societal benefits. And that's something NASA takes very seriously. I was the agency chief scientist at one point. We were very much into how do we parlay the fundamentals into the applied benefits that then feed back into better fundamental measurements. And I think that's been a hallmark, but it does depend on the application area. And by the way, the same is true as we look at other environments beyond Earth, including the fragile environments around the moon as we go there and sustain ourselves as humanity. So very good question. Thanks for listening.
Yeah, I'll just add to what Tim said. I think, it's been a welcome change for us who work in applications to see that applications becoming considered on the front end of mission planning. Obviously, as a science agency, not every decision is going to be dictated by the application or the need. But ultimately, all our downstream science should be addressing something that has an application, something that makes someone's life better. So I think we're definitely moving in the right direction with how missions are being planned now. Because a lot of times we'd always be playing catch up. We would get an instrument launched into space and then realize that somebody could really use it, and we didn't have the ground system to actually get the data to the end user in a fast enough time for them to use it to make a decision. So those are the types of things now that are being considered when it comes to formulation. Obviously, in a world of infinite resources, you could have every observation you needed and wanted in the time frame that you needed, but having that balance between science and the downstream applications is something that obviously I think NASA takes seriously now, and I think it has led at least in this cycle of planning these missions better formulation of the instrument, and then making sure that the people are ready to use the data when it first comes online.
Go back to the room. Yes, question up here.
I have a question for Gemma. Thinking about
global data, global science, but then also boundaries. How do you define Europe for your specific and very intriguing program? What's Europe for your project?
Sorry, it's very difficult for me to hear clearly when when people on the stage is speaking. So could you manage to? I mean, it is difficult to understand. I haven't understood almost anything of the question. Could you manage some way to bring them in the computer or something like that, please? The first question, I did not get the question because it is very difficult for me to clearly listen to the. Maybe I'm the only one because I'm not a native, probably, but
I'll try to be short. How do you define Europe for your project?
Okay. Yes, actually, it's a project centered in Europe, not in the US. So, because my guess, or one of the goals was precisely to decentralize this space history, which has been mostly told from the US perspective. I wanted to give a counter approach to that without, of course, taking into account all the developments that took place during the same period in other places, particularly in the US. But so I have chosen three case studies which are based in Europe, one of them in collaboration with the US, Detector. So this will be my starting point to analyze these case studies, which are made by European institutions, research centers, negotiated within European political arenas. And of course, it will not end in Europe because I probably will find contacts and exchanges with non-European institutions and places and people. But this will be my starting point.
Can you speak a little more to kind of how you define the boundaries of what Europe is or isn't in relation to your project?
The boundaries of what? Sorry?
The borders. I can try. I think we're trying to get at the question of what counts as Europe or not. Like, how do you define what Europe is in relation to your project?
It is not really defined. I mean, Europe. I would. The missions I have chosen are Western Europe, French centered, German centered. So it's a very strictly vision and definition of Europe. So yeah, it's very narrow Europe considering. Yeah. I probably this is this will so the project will be very narrow focused on this side, and this is one of the major critiques I have received so far. But yeah, it's Western Europe and mainly German, France, and the European Space Agency. Very, very narrow. But also because it's the archives I have access to, and secondly because by then the 80s, mostly the 80s, which the project will be focused on the 80s, and these were the main European countries or regions which had active space programs. So it had no sense by then to look at Spanish, for instance, Spanish missions, because there were no Spanish missions.
Yes.
Hi, Matt Chandel, Air and Space. This question is mostly for Jim Garman, but I think others could chime in if they feel like it. So when I think about MOLA and its impact on Mars exploration, I think it was a significant move forward in understanding the topography of the planet. But one of the reasons MOLA was so valuable in my mind was also because you could overlay all the other spectral data that was coming from the Global Surveyor instruments and other instruments that followed, and get these sort of complementary data sets and be able to visualize those on the topography. and tell geologic stories about what was happening in the history of regions of Mars. And that speaks to, I think, sort of robust software tools as well on the ground that were able to do those things. And so I wondered if I could get you to speak to, the role that software played in making that possible, and what developments have happened in software since then, and now that you're thinking about your mission to Venus, what's possible now that wasn't possible when Noaa was orbiting Mars? Or first.
Well, thanks for that question, and I hope the other speakers can comment. So MOLA is the Mars Orbiting Laser Altimeter, the first active optical sensing system, for those of you that don't know, to map an entire planet, that operated on the Mars Global Surveyor between 1997 and 2001, producing nearly 1 billion measurements of the topography of Mars. And the unique thing about them, to go to the point of the great question from the person who asked it, sorry, I can't see you, is that what MOLA did was produce a geodetic framework for all data sets, which was an intersection of data, software, and applications, if you will. So by that, I mean that the measurements being made from an altimeter whose orbit was known very precisely and its position relative to Mars' center of mass allowed those measurements to be geodetic. And that framework allows you to measure changes over time because you can repeat them with similar geodetic or better geodetic systems. And that allows a framework for change detection. And that was always the intention of these altimeter data sets for other worlds, including Earth. In fact, as was once said by some of our members of our MOLA team, we actually map Mars geodetically in a topographic sense, the shape of the land and the ice caps, more precisely than we had for many regions on the Earth by the time we finished that mission, which was fairly ironic, even if the spatial sampling was different. But to your point, so MOLA was rather a heretical, what should I say, measurement system for NASA, driven by science, but also by applications. How do you land systems like rovers, Mars Pathfinder, the Spirit and Opportunity, Curiosity, Perseverance, landers like InSight and Phoenix? How do you land them without knowing the precise position of the ground? And how do you do that in an engineering sense that's most efficient and successful? And NASA's program of Mars landings has been phenomenally successful, going back, of course, to Viking. So that was the application that drove it. But the software elements were the idea that that reference frame, that framework you mentioned, would become the basis for multi-data set correlations, because topography, as measured by MOLA, is actually a definitive data set. There's no fuzz. We know the range to the surface. We calculate it with error bars. We spatially map it. And so it can be used as, as a reference frame for all kinds of data, whether it be dynamics of atmosphere interactions, which drive meteorological expressions and radiative balance, to the nature and winds, to the nature of geological formations and their variation at scales that get as fine as those that we need to land on. So that triggered software applications that move beyond MOLA into the realm of the Earth science altimeters that have been flying since the Shuttle Radar Topography mission on the Shuttle Columbia, which was an interferometric radar mission, but also then the current wave of LiDAR-based, laser altimeter-based instruments such as ISAT-2, which has been in orbit for several years, and the JEDI instrument on the International Space Station that measures ground, but also the, if you will, the ground under the trees. And so these reference frames now have triggered software that allow spatial correlations of things that you wouldn't think about, like how do trees reflect light as a function of time of day as part of the ecosystem response in a given region, like the tropics. And now, as we look forward to Venus, unfortunately, laser altimetry is not idyllic above the clouds of Venus because we end up making good measurements in the clouds, and which is great, but not the question. We're using techniques now that are borrowed from machine vision to make the analogy. So on Da Vinci, we'll measure topography using structure from motion multi-frame imaging, which you can do in your backyard with a personal drone and software, thanks to software developments like the scale invariant feature transform that allows us to put together multi-angle data, produce three-dimensional renderings. You can do that with scanning electron micrographs of things. And so the ability of high-end correlation-based software, eventually, which can be moved to spacecraft as we fly. Imagine going to an asteroid like Bennu with OSIRIS-REx and carrying with us things that can do structure of motion calculations to compute ranges without having to carry more trickier to develop active sensing. So this move of software data processing into the domain space where it's hard to do it, it's a relatively in Earth orbit, is tremendous. And today, last comment, we can actually map Earth using commercial satellite imaging from Maxar in multi-frame ways to produce local area topography at scales of meters, and do it very quickly. And that allows an event response capability that doesn't have to wait for a low Earth orbit satellite instrument to come over. So this interplay of those systems made possible by software and community interest has been phenomenal. And MOLO is one of the first steps showing the value of that perspective. So thank you for that question. And a comment others, please, sorry.
Any other panelists want to chime in on that question, or? All right, any other? Yes.
A quick question. The panel before this, Kelsey Herndon was talking about severe, and she brought up this the point that in Pakistan you have these lightning strikes that are horrible and high death rate. We talked earlier about institutions and how they interplay between institutions and what type of knowledge you're trying to put into the hands of people. Have you, and as part of the applications group, and really this is for Chris as well, but Tim, have you seen any play from internationally where we need this type of information, and you kind of see where your data is actually going and you're involved in that process? And I know Chris with sport, that's part of it, right? So the type of data like this that you can provide that people want. I'm just really curious as an historian to see how that process is working now.
Yeah, so I believe one of the members of the Lightning Group, Patrick Gatlin, was also kind of one of the lead scientists on that particular Bangladesh lightning severe weather project. So he helped kind of work to get it off the ground. And so data from like the lightning imaging sensor played a role in developing those sort of risk maps for people. And then going from there to doing actual prediction of all of them. So yeah, globally quite important. But typically, it's where a lighting scientist will get involved, with severe and provide this sort of information and help them put it into a useful form. And then I guess Chris can probably talk better about how they do this on geostationary stuff.
Yeah, I mean, I think, like Tim said, we, Sport ourselves, we focus a lot on domestic partners, obviously, but we work a lot with Severe, a lot of time providing subject matter expertise from our team to, issues that they experience in their hubs. And it's obviously being in the same building, we're very collaborative with Severe. We have a lot of the same mission when it comes to essentially capacity building and developing these downstream applications. For example, for lightning, one of the things we're trying to do is get into the sense of being able to predict when lightning is going to occur. Right now, lightning safety is very reactive. It's usually when you see, a decision support person at the weather service or someone who's providing decision support at a large event, if they see lightning as it's detected, they can then, institute some, mitigation of, getting people to safety. But what we're doing now is, because we're able to take observations from sensors that we have an understanding, the physical reason why lightning occurs, you can then develop models and tools and capabilities to try to predict that first strike. And provide those decision support people, a probability map that lightning would occur in the next 15 minutes. So, the development of our applications are really based on our ability to take good observations, from these new missions. So the science always, pushing that envelope when it comes to science will obviously always lead to better downstream applications. So we really need those. It's a whole process. And we want, you want to be able to take some of the observations, like with the TIM sensor on the space station. And then with the geostationary lightning mapper has really allowed us, that was such a, science is sometimes a linear growth, and sometimes you have these large step functions where the observations we get from a sensor like GLM allow us to create capabilities we couldn't before those observations were available. So hopefully that answered that question.
Well, and I just want to kind of follow up a little bit just on what really enables applications. So some applications you don't necessarily need real-time data for, but a lot of applications you do, especially time-sensitive stuff like severe weather, lightning, et cetera. So, like the sensor on the space station, Liz, it's on the space station, so we can beam down data like every couple minutes. And GLN does the same thing. And a lot of other, a lot of other NASA sensors, maybe it's only every few hours. I know of one mission, the Cyclone Global Cygnus, it's called Cygnus. It's basically mapping hurricane winds. That seems like something you'd want to have timely. But this was ultimately a science-driven mission, and they just never, in a TI-led mission that had a cost cap, they never had money for real-time data. And so that hurts ultimately the applications of a mission like that. And so you do need this kind of enabling capability of being able to get data like, at least every couple of hours out of these satellites to fill out the full broad perspective of application.
And if I may, this for a more conceptual perspective, this brings back to the question of user-driven or techno-push and therefore right, and this debate which is persistent in all technology, history of technology of all kinds, not only space technology, and what are the users need, exactly who defines this need of the users, do they really exist, and so on and so forth. So yeah, it's also this difference between applications and both science, right? Which has been discussed in history of technology, and so it would be very interesting to someone to explore how this distinction became into existence in the case of the space program. Yeah.
Any other questions in the room?
Yes. I've been, I had answers to all of these too, but I was just interested to listen. I guess the question to Chris and just the community is like, so you heard the severe example in Bangladesh, right? It's actually a combination of modeling as well. And this relationship between sport and severe for sure is great because they set the same building and it's been really great. The question is around listening to other people's demands. So like that question around if you know the lightning is where it is, severe works in certain places. Does sport, or do we have abilities to listen to that demand from other users in a systematic way that you're hearing that we're not responding to because Applied Sciences isn't funding that, or we're not listening correctly? Question is, how do you magnify the implication, the impact of the data that we're gathering? I just was curious to see how we react.
Yeah, I mean, I think, in a general sense, the concept of, capacity building or, doing research operations, everything we do at Sport is driven by user needs. So we don't really start a project unless it directly addresses some of the issues that we're hearing from our operational stakeholders. One unique position we have within Sport is we share an applications integration meteorologist with the local National Weather Service office here in Huntsville. And so he works half the time for sport and half the time for the National Weather Service. And then on, in his sport time, he's out visiting other offices, learning what the challenges they're facing are, and he brings those problems directly back to the research teams at sport, and then we work to address those. I think, applied science should be driven by user needs. We shouldn't be developing something and then trying to sell it to a user. We should be developing something. So co-development is, what the project's been built on. And, I think sport has been one of the projects that has kind of, revolutionized this concept of co-development. And, taking users' needs and letting that drive the narrative of how we run our project. So that's essentially how we measure our success. Now, we also, try to take what we learn and feed that back up our management chain to kind of help motivate what NASA, puts resources in. We're a little bit of a unique project because even though we do a lot of applied sciences, we're actually within the research and analysis component of the Earth Science Division at NASA. So we try to make sure that even as there's a lot of there's a lot of drive for doing science to push that envelope forward, and we support that because it allows us to eventually develop better downstream applications. But the hill I will always die on is that we need to ask people what they need, and that's the best way we see impact. And that's what should be driving at least portions of our scientific development. NASA as an agency, we're kind of there to be a data agency that serves other agency needs who have to make operational decisions. Obviously we're not an operational agency, but we support operational agencies, and I think that's where we've seen our biggest impact.
One thing I'd follow up with, the success of the Bangladeshi project is driven not just by NASA's capability to provide the data, but also this great relationship that Severe has had with its hub system and that sort of thing. But you can imagine there are other areas of the world. I mentioned Lake Maracaibo, where there's all sorts of thunderstorms and severe weather. People, have issues there. That's in Venezuela. The United States has terrible relationship with Venezuela. So you could imagine an application for, say, lightning data there, but it's not going to be built in the foreseeable future. Eastern Congo, also a big lightning capital of the world. That's been wrecked by civil war. There's no safe way to really build. So those are interesting considerations that you have to deal with. You kind of work with what you have as opposed to being able to do all the possible things.
Hey, Mike?
Yes, please. I saw your hand. Please.
Just one comment about all this, because I think it gets to one of the important aspects of going forward, which is we know as a user community that wants to understand environment and safety for population, what measurements we'd like to have. That they've been told for the last 50 years, they've written down, they're in reports. The problem is many of them are unmeasurable, or the perceptions are unmeasurable. So the measurement pull is driven by technology capacity. And so, classic NASA scientifically competed missions live in the boundary conditions of the resource and envelope there as to represent. And that's good, that's good management. But sometimes there are measurements that are revolutionary that we need. I mean, in the case of earth science, environmental aspects, measuring the winds at local scales routinely as an input into obviously weather prediction models to change the latency and all that is critical. They're very difficult to measure. And lots of attempts, lots of technologies. There's a case where a radically transformative measurement scheme could affect both the applied, better forecast, better safety, et cetera, and the fundamental. How do these wind systems work as part of the bigger systems of radiative transfer and balance on our planet? And sometimes those applications cascade with the science. It turns out in that particular case, for example, would probably be easier to do that experiment from space at Mars and learn how to do it there than jump right to do it on Earth, given some aspects, because some of the boundary condition problems are lesser. at our brotherly planet. It's just an example. So sometimes there are feedbacks from things that you wouldn't think about that provide an application benefit when you look at the kind of those technology challenge, but really neat measurements. I mean, and the other one I always remember, which is relevant, not so much to the lightning, but to just existential humanity, is, how do we measure the state of the forests of our planet? I mean, before, biomass was measured by taking a tree, cutting it down, burning it, measuring the carbon. That's not the most efficient way to predict. But now we have space-based measurements that can only get so much better to make predictions that talk about the health of that particular part of the carbon cycle, which is built into fundamental science, but there's massive application. So again, that's the delicate balance in an earth science program where applications are a key plank in that kind of program. And NASA does its best there, but obviously there's areas where NASA could do more, as others have mentioned, especially these short latency observations of critical importance to safety. So anyway, sorry about just bringing that up.
No, that's fantastic. Well, if there's no other questions in the room, I think I am the only thing keeping y'all from lunch. So I think ending a couple minutes early is probably welcome. So thank you all, and thank you to our presenters. All right, y'all have a good rest of the day.
We do have lunch out, just like yesterday.
Thanks.
So go out there, and it is getting cloudy outside, so we're gonna let Tim go first and give us a read.
Thanks for the opportunity.
Oh, yeah, thank you. It's my pleasure.
Just the experience being like doing one in person.
Yeah. I think it went pretty well.
Okay. Apology. Yeah, I'll give you the condensed version. Welcome back to the History of NASA and the Environment Symposium here at Georgetown University. Sponsored. What did I do? Oh. Oh, okay. Take three, yeah. Okay. Can I stand over here? No, I guess I can't. So welcome back to the NASA and now I'm getting it wrong. Welcome back to the History of NASA and the Environment Symposium at Georgetown University, co-sponsored and put together by the NASA History Office and Georgetown. So today we have a panel called Colonization, Geoengineering, and Astrofutures. This is one of the last panels of the day. We were meant to be a panel of 4 people, but unfortunately, one of our speakers is sick, so James Esposito will not be joining us. Instead, we'll have a panel of 3. So who I have here with me, if I can just turn the computer and tilt that down. So we have Caitlin Kosman. Caitlin is the 2022-23 NASA and AHA Fellow in Aerospace History and a PhD candidate in the History of Science and Medicine at Yale University. That's as far as I got when I was muted. Her work uncovers the complex ties among scientific, political, and spiritual imaginaries of planetary environments and futures from the mid-20th century to the present. Using the case study of Gaia theory, she examines the scientific theory formation, community building, and the role of poetics in scientific and cultural movements. And next to her is Stuart Sims. Stuart is a PhD student in history at Auburn University, where he studies the intersections of aerospace, environmental, and oral histories. His research aims to understand the intersection of these fields with the local experience of residents living near space centers. And much of his prior work has examined the process of dispossession at NASA's John C. Stennis Space Center. And he aims to expand his analysis of those relationships to other sites of aerospace development. And finally, with us online is Nicoletta Zampacki, who is a PhD candidate in modern Greek literature at the Faculty of Philology of the National and Capodistrian University of Athens in Greece. She was an instructor at Utah University in the United States and an international student and fellow at MIT and the Harvard Extension School. She is associate and managing editor of the journal Eco-Humanism. So those are our 3 speakers for the day, and we're going to be proceeding in that order. So Caitlin is going to be first presenting her paper, Microbes, Cyborgs, and Gaia 2.0, Agency and Geoengineering in the History of Earth and Climate Science. You don't have any slides, correct?
I do not. Oh. Should I still stand over there or?
I think people can see you on the video. Yeah.
Okay. Great. Well, thank you all so much for great panels the last couple of days. And special thanks, especially to the organizers, Brian Odom, Neil Marr, Davin Groot, and Tizomir Harmony for putting the symposium together. And I also want to thank NASA and the American Historical Association for supporting my work this year as the fellow in aerospace history. So I will get started on my talk. So one way in which NASA has contributed to the knowledge of the environment has been the provision of remote sensing data and associated modeling, as we've heard in this workshop already a bit through discussions of the 1980s Earth System Science Committee and Earth Observing Satellites, Mission to Planet Earth, and those kind of organized efforts. But NASA was also midwife to a concept sometimes seen as an alternative or a poetic synonym to Earth system science, and that's Gaia theory. English atmospheric chemist and inventor James Lovelock consulted for NASA in 1964, tasked with designing life detection experiments for the Mariner B mission to Mars. Lovelock instead developed what would become known as in 1972 as the Gaia hypothesis, relying on remote sensing of planetary atmospheric composition and a cybernetic model of feedback loops to argue that atmospheres betrayed the presence of life because they were in part the products of life. Gaia has been described as a theory of the living Earth and a new theory of evolution. Some of what made the early Gaia hypothesis controversial included suggestions that planetary conditions were regulated by and for the biosphere, that life kept those planetary conditions optimal for its own purposes, and even that the planet could be thought of as a single living organism. All these claims were in some way walked back or clarified in later versions, but part of what's striking about these suggestions is their focus on the constructed nature of planetary conditions and the active role of life in that construction. Lovelock and his essential collaborator, the microbiologist and evolutionary theorist Hayne Margulis, even refer to the atmosphere as a contrivance of the biota in their 1974 article in the journal Tellus. Life under a Gaian framework engineers planetary conditions. Margulis pinpointed the most consequential biological actors in Gaia as bacteria, and she and Lovelock worked together to chart and trace the planetary chemical cycles and their histories. The most striking argument for life's role in constructing the atmosphere, like the fur of a mink or the shell of a snail, as Lovelock put it, was oxygen. Around 2.4 billion years ago, cyanobacteria evolved the capacity to photosynthesize. Lovelock and Margulis refer to this sudden, on geological timescales, and large-scale release of oxygen into the atmosphere in various ways, including as the Great Oxygenation Event, the Oxygen Holocaust, because oxygen was toxic to so many of the organisms at the time, the first Great Pollution Event, and even as geoengineering. Because of the waste emitted from these bacteria, which polluted the environment for many of their fellows, our modern atmosphere is 21% oxygen, and life has evolved to depend on this. This kind of closed cycle vision, in which one organism's waste is another's necessity, is central to Gaian thinking. So is the uncomfortable moral ambiguity of a world not run by human ethics. The term pollution, especially in Lovelock's own writing, becomes a relative attribution. He's fond of quoting Paracelsus, that the poison is in the dose, pointing equally to things like oxygen as like radiation. This leads to one of Gaia's most radical and destabilizing propositions, that the ultimate important harm to protect against is harm of Gaia. Individual species and states come and go, but none can exist without the continuance of the larger system. In 1999's Welcome to the Machine, Margulis and her son Dorian Sagan write that human technology is not different in kind from the other ways in which organisms have incorporated their surroundings into their mode of living, building homes and tools and alert systems out of their environments, from shells to termite mounds. Humans are integrated with their machines, Margulis and Sagan argue, from pacemakers to tractors, and thus machines reproduce and evolve through humans. Technology is part of nature, and even rovers on Mars, at least while in operation, are part of Gaia. Satellites, too, then, are extensions of Gaia, including NASA's Earth observing system turned back like eyes to survey Gaia herself. Lovelock takes this idea even further in his last book, 2019's Novacene, The Coming Age of Hyperintelligence. The most speculative of his books, it imagines an age post-Anthropocene, in which cyborgs, by which he means not human-machine hybrids, but more what is elsewhere called AI, have evolved and taken the helm of planetary management. Unlike many other visions of the singularity, however, this is no dead and darkened world run by machines who have exterminated or enslaved their makers in some existential war. Lovelock writes that Gaia will keep the peace. Cyborgs will realize that they, too, as evolved members of Gaia, must work within planetary constraints. Humans and cyborgs and other life will be unified in a more conscious project of habitability maintenance. This good Anthropocene vision has actually been a part of Lovelock's thinking in some form since 1988, when he first proposed a future Gaia inhabited by evolved sentient machines, so integrated with their environment that they'd forgotten their constructed origins. Throughout his writings, and especially in his later books, Revenge of Gaia and The Vanishing Face of Gaia, Lovelock emphasizes the importance of sensing Gaia, of developing an intuition for Gaia, if human life is to flourish on the planet without putting what Lynn Margulis called our planet mates at risk, or indeed upending the whole system. Lovelock emphasizes that this is hard for humans who live at too narrow a spatial and temporal scale. But Novacene stresses the likely speed of thought and long life of cyborgs, such that perhaps they will have a better intuition of Gaia and thus better capacity to engineer the planet to their and Gaia's needs. Lovelock's Novacene resonates with an idea proposed by Lovelock protege and former NASA planetary biology intern Tim Lenton, along with French sociologist Bruno Latour. In a 2018 science paper titled Gaia 2.0, Lenton and Latour suggest that humanity's awareness of its place in Gaia and turn to self-regulation, whether that's personal or at the scale of geoengineering, constitutes a new state of Gaia. Gaia 2.0 carries echoes of other truths, Biosphere 2, second-order cybernetics with its included observer. Hovering between the prescriptive and the descriptive, Lenton and Latour describe the Anthropocene as Gaia's conscious awakening and foresee human intervention into planetary maintenance for the good of all. They seem to disregard Lovelock's own warning of what an onerous, if not impossible, task it would be for humanity if they were to push Gaia beyond the limits that our form of life confers. Relying on Lenton's interpretation of data and possible tipping points, and on Latour's Arendtian search for a new political order, they represent themselves as cautiously optimistic that, quote, we can improve the quality of the sensor, both instrument and people, that detect the shortcomings and the speed with which we rectify the course, end quote, of both politics and scientific interventions into habitability. The radical naturalization of technology and geoengineering of both Gaia and Gaia 2.0 practically equate microbial release of oxygen, cyborg maintenance of the planet, and human geoengineering. Gaia is a kind of cyborg now, made of organic, inorganic, and technological parts. An illegitimate child of the space race militarism and NASA's efforts at leaving the Earth, she has sometimes been unfaithful to those origins, as Haraway said the cyborg often is. Gaia has embraced other forms of sensing beyond that of remote mechanical eyes and binary worlds, including a kind of gestalt spiritual sensibility, poetic intuition, and paleontological inferences of living agency from the stony strata. In an ironic turn, it seems that some of those who follow Gaia would now turn her back to her origins in spaceships and satellites, reassert a human-tipped hierarchy in the software update or next iteration ship that is Gaia 2.0. NASA, for its part, has quietly begun supporting searches for technosignatures in the search for life outside of Earth since 2018, an admission of technology's integration with life as much as of the possibility of other human-like intelligent life that the reporting has mostly highlighted. NASA and Gaia have both trafficked in the whole, the containable, the steerable, the seen from a distance. And these ways of seeing have built the concept of the planetary environment as something with both physical and moral consequences. NASA's interest has primarily been about the possibility of spending beyond the Earth, of treating Earth as a model, either in their computer screens or in desert landscapes or biological labs. It has largely been focused on Earth only insofar as Earth can stand in as a general example of planet with life. Gaia, while built from a very similar simulation or what-if logic, has lent itself to more inward-focused examinations of not just what is needed for planetary life in general, but the specific coupled life-environment evolution of which humans and our machines are but two of many products. Both simulated wholes, the planet and Gaia, run the risk of holistic oversimplifications. But Gaia's embrace of a perspectival definition of harm brings question of action and consequence more firmly to the foreground of any discussion of geoengineering or other responses to climate and environmental change. The history of Gaia makes such intervention not only a question of which humans would benefit or suffer, aid or obstruct those goals, but also questions of how those always present non-human agents might respond in unforeseen ways. The question for would-be interventionists is not only one of sensing, but also of intuition. If satellite sensing has focused on algorithmic intuitions of tipping points and livable ranges, a sense for Gaia, according to Lovelock and Margolis, must include those silent sentinels themselves and perhaps their future conscious progeny. If the histories of Earth system observing and Gaian thinking are perhaps growing closer again, the question isn't just what forms of sensing and seeing will win out, but how these two modes of thinking will face or perhaps deny their shared history. Thank you.
Great. So we will have a discussion after all three talks have been presented. So Stuart, you are up next. Let me see if I can pull up your slides.
And then do you want me to sit from here and have you direct the slides or?
It's a good question. Whatever works. Oh, where are the files?
Stuart, I think from an audio sample, probably want to get to it.
Yeah.
I don't have a loud booming voice.
There you go.
Does anyone know how I pull up the file folder? Thank you.
So that's a tiny thingy. Makes it a bit smaller. And then maybe we can do this for now. Start with this. So go here,
Ah, there you go.
here, yes. That's yeah, great. Two days. I'm proficient.
All right. I guess. You want me over there? Do you want me here?
It might be better if you're over here, you know, closer to the microphone if we're here.
Plus they want me to the camera.
Yeah.
Hopefully. I don't know if people see or not. Yeah, should I sit? Should I stand?
Whatever you're
It doesn't-
comfortable with.
I'll sit. We established the precedent. Okay. Hi, everybody. Thank you for coming. Just want to say thank you to all the conveners as well. This has been a really fruitful sort of discussion between a bunch of different perspectives. So yeah, thanks for that. I wanted to start with a quote. I had a lot of hogs. My daddy and my whole family had a lot of. They just really, really took them to the slaughterhouse. They'd shut them up and feed them and take them on down there and have them cured for their own use. Alton Keller recalled the destruction of his family's hogs to oral historian Chuck Bolton in 1993. Keller's story out of context seems like an exaggeration or an appealing hook. When paired with First Sight manager Captain William Fortune's remembrances of the wild boars that would chase him up a tree on a daily basis, however, there comes a different, more interesting conversation. Maybe it was Fortune that decided to remove the hogs from the site, or perhaps some other member of management. Maybe some trespassers took his hogs and hid the removal from the notoriously shoddy site patrols that were all around the site at the time. Regardless, Keller lost not only his hogs, but also confidence in how Stennis Space Center and managers at the site operated on the property that formerly belonged to him and so many other people of Hancock and Pearl River counties in Mississippi and St. Tammany Parish in Louisiana. This presentation will highlight these discrepancies and the skew the narrative takes from Stennis Space Center when discussing the site's dispossessed population. In 1961, NASA searched for an engine testing site untouched by human interaction like the pesky urban sprawl that plagued Huntsville, Alabama, which made it unviable for large-scale engine testing for the new Apollo program. Selection criteria for the new site was based mainly on environmental factors central to testing. These included water access for barge transfers, road, rail, and utility infrastructure, proximity to NASA facilities like Michoud and supporting communities, and most importantly, an uninhabited area that could serve as a buffer for sound and potential blast waves as a result of the engine test. An ad hoc site selection committee that was established by the Corps of Engineers and NASA and sent out preliminary site survey crews across the country. Through their initial surveys, the committee eliminated many of the sites for myriad reasons relating to those criteria, until few remained, mainly in closer proximity to assembly facilities at Michoud, which is close to New Orleans. 2 locations in Texas, 4 in Florida, and 1 each in Virginia, Georgia, and Mississippi. The Pearl River site in Mississippi was the top choice of the 9 finalists. It was, according to surveyors, mostly wooded lands owned by the large paper mills in the region, poor farmlands, and densely wooded swamps. It is estimated that there are 300 to 500 inhabitants. Why am I tripping over my words? Anyway, on August 25th, 1961, the committee sent its findings to upper echelons and comprehensive site surveys began in earnest in Mississippi. Residents in the area, of course, heard rumors about a big project coming to their community, seeing unmarked cars and planes making more regular appearances at the time, and were officially told of the decision 2 months later on October 25th by radio and TV announcements. Many residents, though, found out through the rumor mill and became fearful and resentful of the actions that were planned to take all of their towns. They heard that the government would take their land without compensation and aggressively wrote to Mississippi Senator John Stennis, who made a trip down to the Logtown School a week later on November 1st to ease residents' fears. At the meeting, over 1,500 people, irony being 300 to 500 people, anyway, listened to the senator make a case for the rocket site that would force them to sacrifice their towns and ask questions about the process. Many residents wanted to stay on their land or at minimum have access to it. All the while, Senator Stennis spoke of the thorn before the rose, i.e. the process of dispossession resulting from the development. Winfred Moncrief, noted Mississippi photographer from the Civil Rights era, also took snapshots from residents that day, also of the meeting. These are both Moncrief photographs, and placed them in a newspaper article in the Hattiesburg American titled "How Rocket Test Site Folks Feel."
One elderly woman in a wheelchair stayed behind after Senator Stennis's speech and asked the senator, just point blank, what's going to happen to me? Following site selection, real estate agents moved to acquire the property. According to Corps of Engineers estimates, 13,500 acres in the central portion of the site would go towards the facilities themselves. And title for that property had to be acquired outright. An additional 128,000 acres would act as the acoustical buffer zone with restrictive easements on landowners' property, preventing them from living there but allowing farming and livestock cultivation. Real estate agents worked through the central fee area between 1961 and 1962 because of the urgency to initiate construction on those facilities. The buffer zone, however, took more time and wouldn't be complete until 1964, thanks to murky legal processes between the Corps of Engineers and landowners. Throughout the site, however, one thing was assured: habitation was prohibited. During real estate acquisition as well, much of the myth-making behind the Stennis Space Center narrative occurred. Mac Herring, the public affairs liaison turned historian, told the story of local people like Cora Aunt Blue Davis. Legend has it that Davis refused to leave her rocking chair on her back porch as movers peeled her house off the ground and moved it off-site. Herring paired the Aunt Blue story with the stories of the heartbroken elderly residents that died in sudden episodes of cardiac arrest after sudden shock of the announcement told to them through oral histories with people like the well-to-do marina and campground owner Roy Baxter and elderly residents like J.R. Boutwell and J.W. Hoper. Likewise, Life magazine reporter Ronald Bailey portrayed 92-year-old Pauline Weston on her back porch and spoke of her reluctance to leave her home after living there for so long in a 1964 article titled "Moonrace Blots Out a Town." Tying the real traumatic stories of these people with the romantic images of the untouched landscape and communities that real estate agents witnessed on their first trips to appraise property gave the myth more weight. This combination of imagery tied to outsider concepts of backward ways of life, the wilderness, would become the predominant conception of the site's pre-development history. It would continue to captivate the narrative into the present day. Although the dominant narrative continues to control the conversation, other local stories would play a key role in keeping the stories of the dispossessed residents alive. As site acquisition solidified the site's boundaries, residents advocated for site access and opposed NASA's land management practices, mainly with issues involving residents' continued exclusion from property access. People like Alton Keller, the man who lost his hogs, would regularly ask questions like why developers didn't choose one of the alternative uninhabited sites outside of New Orleans where no one lived instead of the Pearl River site. Augustus Elmer, another former resident, wanted to return to his leased property in 1975 to fish. In response to seeing site employees fishing on his property, Elmer reached out to Stennis and site management inquiring about the situation. NASA responded, saying that he was not allowed to fish on his property due to potential liability, though through an employee morale activities program, NASA employees could fish on his property. Other residents, like Mrs. Elsie Cuevas, an elderly resident wishing to visit her family's sinking graves, and Charles Stockstill, a local elementary school teacher, were both denied highway access to visit grave sites and travel to work respectively due to the same sort of liability. It's also important to note at the time when these complaints are being lodged, the two interstates that were intersecting in that previous map that was up there, I-10 and I-59, didn't exist. So people would have to use bumpy back roads and different sorts of ways to try and access these sites that weren't necessarily as viable for people. These very brief examples show us that local people were not silently accepting exclusion from their former communities. Rather, they consistently fought against what they saw as unjust management at the site. Whether it was outright property destruction as with Alton Keller or access prevention like Elmer, Cuevas, and Stockstill, residents still attach their own historical meaning to the site regardless of how NASA used it or managed it. These stories and dozens like them represent an entirely different snapshot of the Stennis Space Center story, full of contested meaning and silencing by those with the power to craft it. Herring's Way Station to Space, both the book and the documentary produced from the book, significantly damaged the story. His reliance on the small number of oral histories provided to him, mainly by local elite Roy Baxter, gave only part of the view. Speaking about other residents, Baxter actively disparaged these people, claiming they didn't know what to do with their compensation. Baxter told Mac Herring, instead of going and putting it right back into a home right away, they probably went and bought a new car and wound up with nothing, and this is inevitable. Likewise, Herring's conversations with site managers like William Fortune also aided in twisting the story when Fortune described residents as scrub farmers with their little scrub cattle that were pretty primitive back in there. These comments from people very close to Herring and Herring's own firsthand memories of the dispossession helped craft the ideas of wilderness and small dying timber communities covered by the pine forests that represented their image in the late 19th and early 20th centuries. These images tied to the myths of dispossessed people crafted by popular media representations like the Life magazine article I mentioned and films like Elia Kazan's 1960 film Wild River created detached local past and reinforced the marginalization of local people within the story. Thanks to oral history transcripts from interviews conducted with other residents and their assorted correspondence with Senator Stennis, however, one can see that these local stories persist. Some families continue to remember their past on the site's periphery, as with Oswald's Sonny Moran and the Peasel Sisters, a famous bluegrass group notable for their role as the voices behind the sirens in the movie Oh Brother, Where Art Thou? Moran's house and his daughter Kathy Hendry's emotional reaction to remembering wearing her mother's oversized heels stomping across the kitchen floor before that site was removed from the buffer zone, and the Peasel Sisters song Logtown that recalled a place gone away from that Pearl River shore highlight this generational damage rather than the narrative of local silence from traditional sources. These interactions help indicate that these stories continue to hold weight for those descendants. The story of dispossession at Stennis Space Center should be central to understanding NASA's relationship with the environment. Its local landscape was and still is crucial to its existence. And rather than the triumphalist narratives of NASA, we witness a completely different relationship between NASA and the local environment when we apply the lens of this history with local people. Residents' loss of property, loss of voice, and their continued removal from the plantation of some 13,500 acres, or the pine thicket, as Lloyd Swenson Jr. put it in 1968, harms them to the point of dehumanization. As Huntsville, Alabama's U.S. Space and Rocket Center represents the story presently, in 1961, NASA decided to brave poisonous snakes, mosquitoes, and the Mississippi mud to build a huge new testing facility. It should be our role to acknowledge this landscape story and represent the voices of the snakes, mosquitoes, and Mississippi mud moving forward. Thank you.
Let me switch places with you so I can pull up big letters.
I feel like we need to play that musical chair.
Yes.
Usually just present.
Are we saying we're pro removal?
Don't be silent.
Good afternoon, good evening. It's me, Nicoletta Zampacchi. I am PhD candidate in modern Greek literature at the Faculty of Philology of the National and Capital.
Yeah. So we don't need that?
Did you want to start it right away?
Oh, yeah. Nicoletta, you're using the video?
Yes. Hello from Greece. Hello from Athens. Nice to join you, and many thanks and my deep gratitude to the organizing committee for this wonderful symposium. Actually, I have to note that I'm also a member of the education team of VINA project at the Glenn Research Center of NASA. I'm studying the fields of the environmental humanities and post-humanities in my wide research. And specifically, I'm working on ecophenomenology, the intersections between human and non-human world, the kinship, as we say, the boundaries of flora, fauna, and humans constantly, diachronically. So the era of the disastrous human impact on Earth systems, recently named the Anthropocene, poses several epistemological and methodological challenges and questions about humanities and the future of humanities, the future of humanism, and the future of humankind, particularly in studying the relationship between the human and the non-human world within a damaged world full of shared precarities, vulnerabilities, and unchosen proximities. Even if the material world is conceived as strictly tied to the non-human life forms, The latter are bound to the human reality as humans are enmeshed within the material flows, exchanges, interactions of substances, habitats, places, and environments. Nevertheless, most public and academic discourses about the relationship of human and non-human world are grounded in an anthropocentric worldview that also entails the belief that human beings assisted by technology can use the planet to meet the needs of both current and future generations. Anthropocentrism, the narrative of humanity's kinship with nature based on our needs, is diametrically opposed to the vitalist approach. The latter is defined by the rise of the politics of life itself, which rejects speciesism and human supremacy, post-anthropocentrism. To go beyond the binaries, we have to overcome the binaries, actually, that underpin the human species separation from the non-human other and jeopardize the planet's sustainability. New modes of analysis and interpretation of these entangled webs of life must be developed. By focusing on the notion of symbiosis, is a Greek-rooted word. Symbiosis is synonymous with the word of interplays. My research actually aspires to contribute to a rethinking of human subjectivity and agency in the 21st century, as shaped by dynamic interplays between nature and non-humans, more than human world. As Francesca Ferrando remarks, once we underline the human, not as one, but as many, some many emphasize the other notions and practices, such as interdependence, symbiosis, affinity, and so on, are as fundamental as the category of alterity. So we have to think about the narratives imposed by post-humanities and environmental humanities, because these two fields of research are, as we say, the most up-to-date in order to think about the future of humanity and humanities. So now I have to share my screen with my PPT presentation, but I cannot share my screen because it says that somebody else is sharing the screen.
I think we have.
Why don't you stop the share?
No, I'm not. Yeah, I'm not allowed to do that.
No, I cannot start screen share because it's currently another in on video.
It's possible.
Maybe you have to close the video or not? To close the file, the document?
I think that unless we have the slides here on this side, we can't share them. But we do have your pre-recorded video. Yeah. So we could play that. Would that work for you?
Maybe I have to read the slides. It's much better, I feel. Because I will lost the flow.
Okay, we will try.
Okay. So, okay, great. Wonderful. Good evening.
Okay, there.
Okay. So my topic is about thinking beyond the future of aesthetics, space art, or the art of space. Or maybe the question is art for space. I mean, the things are very complicated. And actually, I feel that all this kind of research is in progress, as you know, because there are many various narratives to study the complex relationship between humans and modern human world. Actually, I'm working on post-humanism and environmental humanities, eco-criticism, eco-humanism, the ecological perspective, and the future of humans and humanity. When we consider to speak about post-humanism and post-humanities, this means that we don't vanish or deconstruct the humanistic perspective. I mean that our basis is humans, the humanism. So post-humanism presupposes that humans exist, not something that the suffix of post that presupposes that it is the previous and the after. No, but presupposes that humans exist and there is a continuity between humans, modern human world, technology, and so forth. Of course, there are many other narratives, such as ahumanism, metahumanism, transhumanism, transhumanism propels the future that belongs to technology, for example. But posthumanism summons up tangible transformations of humanity to a potential shift to a more comprehensive historical perspective of humankind, and also offers tools to overcome the binaries between human and non-human world. This is traditional binaries and any epistemological limits of human nature. So we have to think about the concepts of posthumanism, posthumanities, and a posthuman term studied in humanities, and mainly in aesthetics and art. Of course, I am from a philological department. This means that we are working on continental philosophy, on a philosophical perspective, yes, and somebody shall be familiar with a continental philosophy, but it's not so, the things are not so complex. I mean that we have to consider and emphasize more on the future artistic practices, because art is much more practical than theory. We can understand through bodies, through artworks, what we have to understand about the future of these terms, actually, in theory and praxis. Popular visual culture and novels, actually, illustrate outer space and living there. Fantasy, speculative art, maybe you have to be in the third slide, yes, if you have to move into the third slide, because fantasy speculative art performs a posthuman perspective of life forms in outer space, where the body meets its interlacing with inorganic life forms. In art, there is actually a flexibility to work with the dimensions, the height, depth, and so forth, and canvas. We have the materials, we have paint, we have colors, forms. So it means that this kind of flexibility through the embodied experience could be the same on Earth and outer space, actually. Yes, great, we are okay there. An artist could work in both spaces with ease and represent the relationship between various life forms with an ease too. Think that all this kind of art is done on Earth, not in outer space. Maybe one day we have to think about painters or sculptors, or I'm not sure if we will live to see such things, but I'm very confident that we will do great things. We will see great things in the future. An artist could work in both spaces with ease and represent the relationship between various life forms with an ease too. The main difference, yes, is the perspective of speciality. We are based on Earth. The things are different in outer space. For example, on Moon or Mars, that we are listening much things about Moon and Mars these days, while working on canvas or material, for example, stone. Although the working and outer environments are different each other, in these two cases, the common practice, the artistic, is same, as well as the intention. The intention is to create art in both cases. So we have to, in my study case, it's about a project called Mars Artist Community. Yes, this artistic project for creating art for or of outer space. We can see many representations of life in outer space, such as planets, satellites, and other planets in the universe. Creating space for outer space means that we have the capacity and the ability to imagine the future of our citizenship there and think about what kind of citizenship we have and we wish to have there. Think that we are based on Earth and we are thinking about what will be there. Who will create art for whom in the future? How can we create art for outer space? Under which conditions and circumstances? It is possible to create art for outer space and art of outer space while based on Earth. Of course, it is all this in our imagination, for maybe in movies or theater, or generally on the cinema. We can see this, these images. You can see that in the first, we have, for example, a space station, not in this, in the previous slides, the fifth one, I'm in the fifth slide, yes, in order. We can see a space station, maybe traveling on Mars. And the second image is about a city, a smart city, as we say, maybe on Mars or other planets. This is very, very wonderful to see the future of on canvas. Or maybe you can see in the sixth slide other pictures of life on Mars. I have a preference on Mars because on Mars we can see this symbiosis between human and non-human world. Yes, exactly. And in the seventh actually slide, we can see some people that are working down on Mars soil, yes, and maybe they are planting something. I'm not sure what they are planting, but this is the survival, this is the aim, to have a mutual accord between the life forms. And of course, the last one is from speculative art. It's impossible, yes, but it's real to think, to imagine how will be our life on Mars after many years. Of course, it is similar with the Earth. Not sure if we will see such images, but think that through the art, we imagine our future and we can speak about this mutual accord between life forms. So how about posthuman aesthetics? How about posthuman aesthetics? Posthuman aesthetics is not separate field or branch of aesthetics. In order to think that something has been previously considered from something else, the prefix of post. So posthuman aesthetics presupposes, of course, a knowledge on traditional aesthetics, the aesthetics of Kant, the aesthetics of Nietzsche or other Heidegger, for example, Merleau-Ponty. Yes, we have to think about the philosophical background and to think beyond the binaries between human nature, nature culture, technology nature, because the things are always changing. The non-human agencies can be considered as active participants in the artistic creative process. You can see flora and fauna that are protagonists, as we say. You can see not only the humans, all are protagonists, actually. Our objective is to set the coordinates for an outer spaces aesthetics that can encounter ethics following the Guattarian tradition, as well as becoming on the epistemological, fostering the performativity of artistic practices and their ecological constitution. However, we are not offering a critique of such artworks. Our aim is to signal the emergence of a trend and how we term a humanist aesthetics of the posthuman. Of course, we have the concept of mirroring. We reproduce images of our daily life. Of course, all these images are similar to Earth, to daily practices that are held on Earth. Means that there is a reinforcement of the humanist perspective. Of course, we have to focus that all these issues, as we say, there are posthuman aesthetics does not mirror the world, offering various artistic representations, but rather is capable of recognizing the range of its ethical imperatives, which involve a creative conjoining forces of the universe. So we can see that there are many and various topics with different areas and themes from universe, life on Mars, on Moon. I prefer this with Mars because are much more, as we say, representative. And these works are in a different aesthetics operationality and aesthetic mode of acting by humans. I have a quote from Gilles Deleuze in his book dedicated to Francis Bacon, writes about a common problem that concerns art and the creative process. In art and in painting, as in music, it is not a matter of reproducing or inventing forms, but of intercept forces. The art of space and the art for space express the capacity of aesthetics to intercept cuts and be impacted by forces that is to relate, offering a perceptual juncture. So depending on which artistic exit to the posthuman future we choose or which artistic exit chooses, we argue that a very different posthuman art future will ensue. Of course, moving from a mere and traditional creative process to a field of cosmological relationality, posthuman aesthetics is the becoming of pluralities and alternativities, allowing different forms to be in a mutual accord in canvas before they traveling, of course, in outer space. So we are thinking about the future of our citizenship. This kind of citizenship is a symbiotic citizenship. I must admit that I'm working on symbiosis and the Gaia hypothesis of Lane Margulis and Lovelock, yes, but I am concluding in my research, which is actually in progress, that citizen humanities is the term for citizen science in the humanities. Of course, we have the tools, data, smart practices, you can see smart cities, the rise of all these issues, but the priming of this symbiosis metaphor in a planetary political arena could signal an affirmative mode of human relations to multiple others and encourage the research on what it might mean for our daily lives as well as for the citizenship policy. So we have a symbiotic stewardship, which could be theorized as an active shaping of united trajectories of post-humanism and eco-humanism actually to enhance the sustainability of human and multi-human world, not only on Earth, but in outer space. So this co-shaping brings new issues about the perils of blurring borders or blending interests between human and non-human or more than human, and actually think about a symbiotic future and symbiotic citizenship in outer space, which actually I hope to see. Maybe we travel one day there. Thank you very much.
Oops. Okay, I'll put up the opening slide again. And now we can have some discussion across the three talks. So are there any questions from the audience about any of the three talks? Yes.
This is for Kaylin. I would be curious if you could talk a little bit about this concept of planetary boundaries as it might be distinguished between the Gaia people and the Earth systems people, like, because both of them kind of play with it. I know the tour plays with it. Lovelock probably didn't, but I don't, maybe he did. But I mean, it seems to me that in a certain type of like theorizing about the Anthropocene that's really relying on Earth systems, I'm thinking of like Julia Thomas's book, that's co-authored with some people, some physicists, geologists. There's more of a like, there's less of a pro-geoengineering type of idea with planetary boundaries, whereas the Gaia one kind of is pretty comfortable with geoengineering. It's like we need to engineer our way out of the boundaries, or at least create new boundaries and reconfigure them. So I mean, I just like on sort of more of a philosophical level, do you see them playing with this concept in different ways or not really? Or
yeah, definitely. And I would say too, like, I mean, people, the way that Lovelock and Margulis themselves think about Gaia changes over time, and also the way that other people think about it is various. And so I don't know that everyone who would say that they are interested in or use Gaia theory as an analytic or as a scientific program would necessarily be pro-engineering. But what geoengineering, what I think is really interesting is these moments in Margulis's work, and then certainly at the end of Lovelock's, where he sort of said, like, it's as natural as anything else that life has done, and that therefore it would sort of be allowable. But in terms of planetary boundaries, I think that this is also a little bit variable, because I mean, both ESS and Gaia have this kind of focus on the sort of feedback loops. They're focused on life as a planetary bounded entity. That sort of like Gaia is the emergent entity that is these living and non-living interactions. Latour is now working with a lot of scientists who talk about the critical zone. And so I think they generally share that. But there are these sort of like breakthrough moments where they seem to be thinking more speculatively within the Gaian framework about things like, if the rovers are still talking to people on Earth and they're on Mars, like, is that somehow part of the Gaian system, because there's still that connection. It is an action of living organisms that is like out into the environment. But it's also sort of temporally bound. Like, it's sort of while they're in operations, they're a part of Gaia, but once they can no longer communicate, the implication that Margolis is saying and have is that like at that point, it's sort of no longer part of Gaia. Another two brief things I will say about this question of sort of planetary boundaries is that one of the things that I think is interesting about some of what I've read about the early sort of setup of the Earth observing satellites and that sort of like ESS version of thinking about the whole sort of planetary system. And some of what I've read was talking about the sort of like thinness of what could be observed with that kind of tool. You couldn't go deep into the ocean, or you couldn't simply go deep into the ground, and that it was sort of like a more surface level attentiveness. Whereas I think what's kind of a little bit different boundary, perhaps, with some of the Gaian thinking has, it could allow more investigation of some of these like deeper things that can't be seen by satellite. And it certainly has much more interest in sort of thinking historically to things that can't be currently measured. And so temporal bounds might be a little bit different. Yeah, and then there's the way that Margolis thinks about the planet is perhaps autopoietic. So like the idea of the autopoietic cell. That's another way of thinking about boundary is something that is constructed actively, that is like a self-maintaining boundary. So there are actually maybe a lot of ways. Not sure if that really answered anything, but
I'm sorry, that last part though.
Yeah.
So it's like essentially an idea that the planet creates its own boundaries through its Gaiic process or whatever.
And that's something that Margolis talks about a lot, but Lovelock himself doesn't pick up this word. They both met Francisco Varela and Humberto Maturana, who were the two Chilean biologists that came up with the idea of autopoiesis. And they both met them at this institution that I look at called Lindisfarne. But it was really Margolis who took that on and started talking about Gaia as kind of like the largest autopoietic entity. And so in her later work, that's more often the kind of like framework that she will use. And it's about self-constructing of the boundaries.
Yes.
I have a follow-up question. Is there any discourse within like, Gaia thinkers about like anti-capitalism, or is it more of a philosophical, cultural, like changing people's worldview? Like is solar punk involved? Is what's the other thing I was thinking about? Degrowth, activism, or kind of theory involved, or is it particularly trying to just break down like a human-centered kind of conception of how the world should be organized?
Yeah, that's a really great question. I think like what I have mostly seen comes into sort of two camps. One is that I think there were some people in the 70s and 80s who were in sort of various kinds of countercultural and new age communities and also some global governance who were all interested in the possibilities of Gaia. And so some of them were thinking along the lines of what I think sort of becomes sort of degrowth type thinking. There were a lot of economists at some of these meetings at Lindisfarne, but not with exactly those words. But they were certainly trying to think about if we want to reimagine those, like, the we in that case being the people in these conference rooms, right? Like want to reimagine what the world could be. And Gaia gives us some kind of vision on that, that, human ways of living might need to change, and that often they were much more sort of one world thinking, but it was also tied up with a lot of this like population, overpopulation discourse. So degrowth also in a sense of like fewer humans was sometimes part of what was picked up. And then I think today too, some of the scholars who have turned to Gaia, it has been a lot in this sort of what's maybe more of like a first step thing, sort of like what Nicoletta was talking about in terms of like decentering human. But that also comes with certain kinds of like radical politics that are sort of like assumed to come along with that. I think sometimes and not always as spelled out, certainly in like Haraway's interest in it, right, and things like that. But solar punk, for example, like I don't know, I need to look into that. And in terms of like current people writing more directly about degrowth, I also don't know if they use evidence to follow up on.
Thank you.
More following Stuart, my question is for you. Yes, we started talking about this a little at lunch yesterday, but when we were talking about the
I'm curious if the rationale or the way the rationale for displacement was conveyed to the citizens of the tower, since actually Rachel's talk yesterday about acoustic risk. So I'm wondering how those forms of risk to the inhabitants was conveyed to them in terms of like actual environmental risk, whether it's kind of more ephemeral kind of sound or kind of more material or bodily risks. And related, I'm just looking at the new exhibit, one of the new exhibits there in space, they talk about Allenhurst, right? The Friedman founded town in Florida that was cleared to create the vehicle assembly building. So I'm wondering how the displacement or dispossession of people in that part, in the Stennis kind of area, how does that compare to other instances of displacement for the creation of space infrastructure in the South of Europe?
Okay, broad question.
It's fine.
Yeah, no, that's actually a really good question. And I wish I had more time to talk about it. But so in terms of Stennis, anything that I've come across the record, there really hasn't been like any conveyance of risk per se. It's more so a conversation of sort of establishing international prestige, making a sacrifice for the space program. It's a lot more. It's held in more of a jingoistic light to try and like beat the Soviets to the moon kind of thing. Stennis literally says it in his speech when he's giving it to residents that, you know, you're sacrificing your homes to make NASA do what it's able to do. They're able to go to the moon because of the sacrifice that you're making. So in terms of risk, it's not really stated to residents, but you know, in terms of like Huntsville, you know, that's a lot of the conversation as to why it gets moved to Mississippi, because people start you know, making these complaints about the fact that like their houses are rattling too much or they're too close to the engines and they're afraid that something's going to break or fall apart or anything. And, you know, they try to mitigate that by making up these cartoon pamphlets with cartoon characters like DB Noise that, you know, says it's okay if your house rattles a little bit, it's not a big deal if nothing gets broken. So in terms of the risk, you know, risk doesn't get portrayed as much in the Stennis story because it's played more in the sacrificial light, I guess. Does that answer your question?
Yeah, it's the whole front of the space race in some ways, right?
Yeah.
It sounds like a lot of the same discourse that you'd see from over. That's really interesting.
Yes.
A question for Stuart. Could you tell us a bit more about the sources of oral histories that you've been looking at? So why were they recorded? Like, was there a program that was out documented being dispossessed, or is part of the general wider sort of catchment?
Yeah. So most of the oral histories were conducted with the University of Southern Mississippi. They had a joint program with the Space Center to record a lot of these stories. So they have some that are under the umbrella of like the Stennis Space Center Oral History Project, and then some are located in this, what's it called? I think the Southern Oral History Project. It's some other very broad term that they kind of use as like a catch-all for everything else. And it's really interesting to me to see what's included in the official narrative and what's not, because pretty much most of these interviews are conducted while Mac Herring is still the side historian. So he could have easily used a lot of these other stories to talk about these people. But yet for some reason he relies on this one guy and this one narrative that's being provided. So that's most of what is coming out of that story is like, you know, he's got this beautiful source base. I mean, I use it. Like these interviews were conducted in the 90s. It's not like they happened 2 days ago or anything. So it's like he easily could have pulled from them, but instead he just chose to rely on, I guess, his friend or, you know, somebody that he relates more closely to because he's in conversation with Roy Baxter a lot in the narrative.
I have a question for all three of you. So I wanted to ask you about, it seems like optimism plays a role in all three of your talks in terms of, you know, Stuart, you were just talking about how, you know, this was folded into kind of a narrative of this is going to help us win the space race. This is all about national prestige. It's to be viewed in that light. And also in the museum exhibit that you shared a piece of this idea that even the scientists and engineers were making sacrifices here, moving into the swampland for the national good. And Caitlin, in your talk, just latching on to one part, you know, this idea that artificially intelligent machines are going to see themselves as part of Gaia and work to regulate it as opposed to destroy it and replace it with a machine when, you know, the people who built them haven't been that intelligent to do those things. Seems very optimistic. And, you know, Nicoletta, it seems like optimism plays a pretty large role in the space art that you showed, in that regardless of what model was being sort of depicted, humans were succeeding and doing things on other worlds and out in space. So I wondered, if the three of you could each talk a little bit maybe about the role that optimism played in either the stories you're telling or the historical figures that you're sort of unearthing in your research.
Yes. May I start? Yes.
Yes.
Yes. Great. Good question, because yes, we are very optimistic about the future, but we have to think about the problems, the inconvenience, or maybe some issues that we have to face. First of all, I have to start with the machines and artificial intelligence. Yes, there are many projects out there that, for example, we have machines or robots that are painting, robots painters such as Ada, or even now, or many robots, or Sophia, for example, that these robots, for example, promise yes, an optimistic future that we will win and we will survive and so forth. But this narrative of transhumanism that propels that technology is the only solution for everything, or maybe, for example, a robot could even paint in outer space, not only on Earth. Okay, but I am supporting, of course, the humanistic perspective. Of course, there are difficulties. For example, if we have to travel in outer space, we have health issues. We have to take care about the conditions, the oxygen, many problems in order to paint with joy in outer space, for example, our life there. This is, of course, something, a utopia for someone that is hearing such a thing. But think that science fiction, movies, and art actually is the way to think at some capacity our future. Actually, I am working on another concept and another field of research, which is called biomimetics. Biomimetics is a space that we have to adjust or even adapt technology and to think for smart practices and natural patterns and designs in order to make our life easier in outer space. I mean, we have to mimic, as we say, for example, bees, in order to create smart machines and applications such as rovers or similar machines in outer space. Yes, this is in some capacity solve the problem because we, I would say, bring into mutual accord nature and technology. Of course, we're very optimistic because we are young enough to think about the future. I feel that there are the dystopia that is in these issues is a huge one, but through the art, through science fiction, through popular culture, through this speculative, as we say, genus, we have to emphasize more on the future. There are many voices, I must admit, from my experience I have seen in my research actually and around humanities. There are many voices that support transhumanism, humanism, and not the anthropocentric, as we say, perspectives and anthropos and human and so forth. They believe that technology and machines is our solution and we will send them in outer space and everything will be fine. But I feel that we have to think that humans is the base. We will have to think about our future as humans there. It is impossible for me to emphasize our life in outer space. There are some, you can see that the images that they are painted are from our daily life. I mean, planting, watering, many practices that are same on Earth. But this optimism is, the source of this optimism is that we have secure, as we say, we are secure to speak about what we have now. I mean that we are not we are not very confident to speak about the future many years ago. But my thought, my perspective is that nature and humans will be the base, nothing more, nothing else. Think that machines and artificial intelligence and everything is created from us. I mean that humans will be there. I'm very confident under which conditions we will find some solutions, I feel, but not now, maybe some years ago. This is something that I'm very optimistic because there are many is much progress in this direction. Yes.
Thank you. It doesn't matter. I mean, I can go, it's fine. So, you know, I would say, I think, yeah, my story's full of optimism, especially in terms of the scientific narrative that goes along with it. But I think also what's really interesting too is that there's also this kind of optimism that comes from local people lodging these complaints with people. I mean, I feel like if you're not optimistic that something's going to change, you wouldn't talk to people about trying to fix something, right? And I think that that's another one of the really interesting perspectives of this is that, like, you know, it's really interesting to see people try and wrestle with that and talk through it. And let's see, I had a thought and then I lost it. Wow, this is great. This is what happened on a Friday afternoon. I mean, yeah, really just a lot of, I think too, though, there's, you know, you didn't want me to talk about pessimism, but pessimism is also very readily present in all of those stories as well. So, you know, that's, yeah.
I didn't say you couldn't talk about that.
It was implied. I'll steer clear.
Yeah, no, I like this question a lot because I think that this is what is so wild to me about Novacine and about some of Lovelock's thinking is this, like, have you met humans? And some people would be having met like the history of colonialism and racism and everything else, right? Like, so it's wild to me. And this is what I think is like so interesting and so dangerous about the way that the denaturalization, the decentering of human and the naturalization of sort of pollution and human action, all this is like, yes, like post-humanism like puts forward this utopian, beautiful vision where we're all going to live together in Gaia. But like, that would be nice, but like, even if it is just organisms interacting, there's a lot of harm. I mean, oxygen killed off like many organisms, and that was harm. And like, if they did it in the past and we now rely on an oxygenic atmosphere, does that make it okay? Not necessarily. So I think that there's like that aspect of like the optimism feels a little bit nerve-wracking when you like look at some of the histories of violence between humans, like let alone then humans on non-humans. And yeah, I mean, Novacine is just wild to me that like, he's just like, yeah, it'll be fine. Like I have not read Sophia Noble's book, apparently, Lovelock says, because like, you know, we don't worry about algorithms and we don't worry about like what's built into them. You know, it's just, yeah, it's wild. It's wild to me. I'm not as optimistic as he is.
Yes. Hey, I have a question for you. You know, Latour talked quite a while ago about we've never been modern. And I'm curious in the Gaia philosophy of questions of reaching human modernity comes into this conversation. And then the other side of it is the accelerationist theory, which is that in order to get out of capitalism is to accelerate it. And I'm just curious how in any of the Gaia stuff that you're looking at, does that show up?
Yeah, that's really interesting. I'm sorry. Oh, yeah. Okay. Yeah. Okay. So, I mean, the latter one first, like, I actually have not come across direct conversations about acceleration theory and Gaia. There may be other stuff. I feel like I'm always learning that new people are working on Gaia because it's like one of these things that just, so there may be something out there. Sorry, remind me the way you phrased your first part of the question.
Well, I'm just curious.
Oh, no, we've never been modern. That was it. Yes. Yes. I mean, I think that that's weirdly like Gaia 2.0 is kind of that moment, because I think before that framing, the interpretation that I had gotten was that most people who write about Gaia, it's sort of like, it's much more of a continuous view of a sort of like humans are organisms on a planet with many other organisms with agency, and we have not been the most important. I mean, Lovelock was originally sort of resistant to the idea that CFCs could harm the atmosphere, because he's like, well, how could humans, like, no, we're not important, like microbes are on Gaia, right? And it took a while for him to go, oh, I guess we can also do things. And so in the sense of like, if modernity, which like can mean many things to different people, but if it means something closer to what sort of like Anthropocene discourse is talking about in terms of like a kind of agency over the environment and a kind of control and sort of power, I don't think that has been as central to the Gaian thinking until we get ideas like we are now Gaia's consciousness and we'll run the planet with, you know, the Gaia 2.0 kind of language. I don't know if that exactly answers the question, but yeah.
I know, but isn't that a break in Latour's thinking then? Because we've never been modern, is that we, like, the whole conceit of modernity that we've escaped and separate ourselves from the social from the natural is a fantasy. But some of the Gaia 2.0, I mean, it's kind of, I'm sure he has much more brilliant ways of reconciling this, but it kind of mimics the whole, maybe not in Latour, but a lot of the guys kind of mimics the whole, like, we will transcend natural bounds by becoming the one control mechanism in this new thing, right? So I don't know. I see contradictions there.
Yeah, yeah, and I think it's interesting because I think part of it is what I see in some of, because Latour writes that book about Gaia. He gave the lectures and he wrote the book. And then he writes a book after that where he actually turns away from down to earth, where he turns away from the Gaia model and says, actually, Gaia isn't the right one, and we need the terrestrial. And I think this is like part of his, because I see like what's driving him here is really an interest in sort of a political order and a new sort of political sort of citizenship, maybe, right? Like he's very interested in sort of like how these ideas can bring our social worlds and our sort of experiential worlds back to a better place, or to a new better place perhaps. And so I think that that's part of why you see these tensions and sort of like Gaia's the answer, no, Gaia's not the answer, it's this. We're one of many in the sort of A&T framework, or maybe it's a little bit more hierarchical than that, and there's some place for humanity. I really think that that's partly just because he's sort of looking to, like, what do we do with the Anthropocene? What is the politics of the Anthropocene? Like, how could we change the world to be sort of like in a place that he thinks is sort of more politically and morally. That's why I was saying sort of like an Arendtian thing, like, you know, so I think about like her concern about like leaving, right? The idea of like, there's no future when, like, no political future is possible if it's like this sort of like endless progress narrative. Like that, I see him as kind of in that vein.
Can I interject there?
Mm-hmm.
Just having worked with Latour or being a part of this critical zones exhibition, or is it like Hayne, Germany? Do you have that book?
I have read sections of it, but I don't own it. Yes.
I wish that we could somehow teleport you there to Karlsruhe and back in time, because I think you would have been transfixed with how large it was, how far ranging, and how many different scientists they had there. And they had my photogrammetry from the Rock Art Cave in Patagonia, and then images from Mars, from my dad's Viking missions, and merging all the scenes about volcanoes with like a Athanasius structures, Mundus Subterraneus. But it's massive. The number of scientists that we have in looking at critical zones, but also artifacts from the Margus and from the block that were just amazing. It would have just been like, oh my God, I can't believe I've seen these things. But just want to interject here. I think a lot of what Latour is doing right now in sitting down with them and talking, you know, about his goals for this, I think a lot of it's apology or trying to backtrack. Like he's so like, oh my God, we took me too seriously with laboratory. I think like construct and artifacts. Like wait a second, because there are like we have biological creatures. We die if we don't have the right amount of oxygen, and we have. I think there's a desperate backtracking going on right now. Like he wants to make up for some things. He's trying to find the best way instead.
I think one of Latour is like really invested in pre-lab ceremony imaginary, and that's what we should be trying to return to. That's the impression I get. We've invested in a very particular Western European imaginary of what the ideal landscape is, and that's like a lot of support, that there is a right thing that it should be, and that that's what we should return to, rather than trying to work with the damaged planet, right? More and things.
Yeah, I mean, I think both framings carry possible problems, right? Because the any kind of like return narrative can be that kind of like, we'll return to the before the fall kind of problematic, like Edenic, pre whatever, that like carries I mean, did that ever exist? And also usually that involves a lot of othering of certain kinds of human life. But like the living on a damaged planet carries problems too, because sometimes that like creates an idea that the crisis has already happened and it's over and is unavoidable. And there's like it's like, oh, it's fine. We'll just like live over here and we won't try to change anything. And sort of it can, I think the problem that I have sometimes with Anna Singh, although I sometimes love reading her work, is that sometimes like, are you valorizing precarity in a way that like is then like means that no one's going to help the precarious, right? Like I think there's like there are dangers to that way of thinking too. If you just assume that everything's already ruined and you have to sort of make do. And also, I mean, like not to get on a thing, but I mean, like the mushroom at the end of the world, like they're still participating to some degree within the structure. Like those sort of para-capitalist spaces can exist because the main structure still exists. And so it also only operates in this sort of interstitial space. If the main structure disappeared, like would that still be possible? I don't know.
Yes, Anna.
Yes. Really down to us and not
like to be.
Thinking about like creative industries. What was the racial ethnic makeup of the dispossessable?
Yeah, no, that's a good question. From what I remember, statistics wise, around 96% of the population when they dispossessed the county was white, which is actually, a lot of people they're surprised when they hear that. They're like, wait, it's not white. But there were at least 300 Black residents of the area that were dispossessed in the process. So
were they featured in the oral histories?
they were not featured in the oral histories, but there were a series of newspaper articles about Black residents that were dispossessed. So they are represented in some form in the narrative.
It looks like it wasn't on the agenda for the oral historians. So yeah, that's right. That's
We could definitely get into that conversation too. Yeah.
That's get biased.
Yeah.
Historical record. Yeah. Thank you.
Yeah.
Can I follow up on that though, to ask, was there, it seems like there was nonetheless a sort of othering of parts of that population, large parts of that population. Absolutely. Yeah. And sort of ideas of who is participating in progress and who is sort of stuck in older ways. Right. So that seems like a very interesting component of the story.
Yeah, no, they definitely in ways they try to include them like in these conversations. Dennis again does highlight the fact that they're making an effort in part of this by surrendering their towns and their communities, their ways of life for doing this. But at the same time, they're still saying, well, we're not going to give you a job. It's not like you're an engineer. You can't help us do these things. So we're going to bring all these people in from Huntsville or some other area to operate the facility. So, it's still this weird sort of middle ground of you're helpful, but not. Yeah.
Yes.
All right. The second question, double dipping here.
So
Stuart, the broader framework of this dispossession was it, at least in large scale newspaper publications or through NASA, marketed as Southern modernization, in the way that other Cold War installations marketed themselves that way, or is this kind of a very idiosyncratic example that doesn't fit that mold?
So I would say that there are, It's hard to say because there are very few accounts of it happening. I mean, besides the Hattiesburg American, the Biloxi Sun Herald, two of the local newspapers where they talk about it somewhat extensively, there isn't that much out there for them to talk about. But usually, you know, there are plenty of parallels that you can see with a lot of the other conversations that go along with similar sites that get developed in the 60s and, you know, around the Cold War context. So, again, it's a weird sort of like it is but not kind of thing. Okay. Yeah, Mississippi's a strange place. This side is a strange thing to have to study.
I have a follow-up question too.
Yeah,
that's okay.
go for it.
You said something about somebody referencing, making the analogy that this is like being dispossessed from a missile test site.
Mm-hmm.
Was it widely known? Because like my research relates to missile test sites and dispossession. Was it widely publicized that, you know, people whose lands were once on what is now missile grounds had been, you know, displaced, dispossessed? Was that a narrative that you found to be common? And also, I'm sure you have, but just in case, have you read Range Wars by Ryan Edgington at all? Okay. I don't know if offering recommendations after presentations.
Absolutely.
I think we're not. It relates to dispossession on a white sands proving ground missile range now. But it's New Mexico.
Mm-hmm.
But similar things.
Yeah. So in terms of the missile conversation, it's interesting because, again, the site's devoted to just engine testing in general, but they do sometimes call it a missile site in terms of like early accounts. So Stennis did call it a missile site when he went to the Logtown school and told these 1,500 people that they were surrendering their land. He was like, oh, it's for a missile site. And people kind of referred to it as that until they eventually started testing in the 60s, like in 66, when they completed construction of the site. They finally realized, oh, it's actually for the space program, not for missiles. But yeah, there's kind of that overlap there.
Okay.
Did that answer your question?
Yeah.
Okay. Just want to make sure.
I have a question for Nicoletta. So, you know, when you're considering space art, how do you decide sort of what is within bounds? Because it seems like you're interested in, you know, art in sort of the conventional gallery sense, but also popular culture and the imagery that comes with popular culture. You know, how do you sort of draw the scope of your project? And do you treat the types of work differently depending on what audience they were intended for? Or maybe this is not even relevant to the way that you're approaching the art. So I'll let you speak about it. Thank you.
Great question. Actually, I'm always thinking as a researcher about the future of terms and perspectives. I mean that we are always talking, all scholars around environmental humanities, post-humanities, public humanities, digital humanities, that they are involved with these disciplines. They're always talking from the humanistic perspective. We are based on Earth, and the narratives and discourses are created from us, shaped from us. I'm thinking when we travel, again, I'm optimist here, when we travel, for example, on Mars or Moon, the people that colonize the planets, the satellites, will maybe have different perspective from us now. I mean that all these discussions about the future will be deconstructed. Maybe they will see from another perspective, from Martian perspective, from a lunar perspective or other, or I'm not sure about what kind of perspective. Maybe they will just, as we say, set barriers and make a distance for what we are talking about, the future of them, the future for them, maybe. Yes, this is something that we have to take care, because there is fluidity between discourses when working. Now, of course, we have the convenience to talk because we are based on Earth, but the things will be different based there. My research actually, because I'm working on environmental humanities mostly, I'm not a scholar that's supporting the voices of transhumanism or even post-humanism totally, but I feel that we have to consider as symbiosis, to find, as we say, the balance, because when we are working on topics about ecology, nature, yes, and technology, from the other side, robots, artificial intelligence, we have to find the balance and see in which capacity, which are the differences, the commonalities between human, multi-human world, if we have to think about their mutual accord, the mutual living of all life forms in praxis, because think that art, this is something that we have to take care, practical things, applied, as we say, not just in theory. In theory, nobody could even care about theory and philosophy in the end of the day. I mean that we have to think in praxis how these symbiosis of life forms could be done, is possible to be done, in which conditions, is it possible to be done in the end? I feel that it is possible, but of course we have many things to do in progress in our research, but in which capacity? Because when we are thinking about the interconnections between nature and technology, we have to think about the future of nature. Maybe nature will be vanished in the end and technology will survive. I mean that we have to be careful and to think about under which conditions, to set some questions on ourselves when creating something. But art, science fiction, as we say, because I'm literary scholar, science fiction is much more practical to understand. We can imagine, actually, yes, this is something positive, utopias or even dystopias, but we imagine, we have this convenience, the path to imagine. I have to refer, actually, many jargon, there's much vocabulary in these fields. I must admit that environmental humanities, post-humanities, they are full of new concepts, new ideas, new narratives, and in the end, maybe somebody that is not familiar with all these things will be lost. But we have to think about the major, as we say, vocabulary, and set some questions about what kind of citizenship, under which conditions, under how about the requirements and all these things. There is actually a term that raises my interest in my general research, because now I will be graduated in 2 weeks as PhD holder, but actually I'm thinking about the term of symbiocene. Is a memo, as we say, is a meme term, like Anthropocene, Symbiocene, Capitalocene, many scenes, as we say. Yes, this is something, as we say, promising and optimistic, but Symbiocene is what kind of scene is this? I mean that Symbiocene is possible on Earth, under crisis, under pandemics, under everything that is around us, or maybe is a new era, something that we have to work, imagine, or even Symbiocene. Yes, it raises my interest, and actually I'm working on post-humanist ecologies, smart biocities, how we have to apply technologies in order to create smart tools, gadgets, not only on Earth, in outer space, actually, biomimetics, biomimicry, and all this stuff. It is very, very important to think smart things and to bring nature with respect in nature, not to protect nature, not to destroy our habitat, because Gaia is Earth is our home, ekos. Ekos is Greek-rooted term, which means house, our Earth, our house. So we have to protect, and there are many, many projects around as we say, outside academia. The smart robots that, for example, there are digital or smart sensoring models and robots that these robots can, for example, be adjusted in high temperatures, or even we can explore natural patterns, or use, for example, fleas, bees structure and shaping in order to imagine rovers. This is something that NASA has already done with Perseverance and many other machines that sent, for example, on Moon or Mars. We choose Moon or Mars, not other planets. I mean that these two actually is what we have to, for now, to hear. But biomimetics and biomimicry is the future. And we have to think about if it is discipline, if it is connected with engineering. This is some questions, because United States of America, Canada, these countries are working on biomimicry and biomimetics, not in Europe so much, only in Germany, and actually some countries in Asia, not and other countries. Yes, in these directions, yes, if I'm answering the question.
Well, it's 3 o'clock, so that's the end of the session. So I want to thank all 3 of our presenters for great talks.
Thank you very much for joining.
And thank you all for coming.
One second, real quick.
Yep.
Just to kind of close it out here real quick. I know we've all got flights to get to and that sort of thing, but I want to say thank you to everybody for being a part of it. I mean, you know, if it's NASA and the Earth, NASA and the Environment Symposium, it's just me, it's not as fun. Right? Yeah, so, you know, thank you to everybody for this on. Thank you to like Andrew for helping out with this. Obviously Georgetown for presenting DC Space Grant Post, NASA for, you know, helping out. But it's you guys, right? That's what this was about, getting the community back together. That's been a hard time, right? But I think I've seen a lot of excitement about being back together. This is not, you know, these symposia, they're supposed to be like, you know, family getting back together. So I think that's been really important to me, to see people interacting and enjoying it. So I know I've learned a lot. And this isn't a data dump, right? This is the beginning of all of these different streams moving from here, just like what we talked about. So I appreciate it, and thank you for being part.
Thank you.
My God.